Hello, everybody. So welcome to this Dataport session in the European Big Data Value Forum. So my name is Santiago Cáceres. I'm going to chair this session. I'm in fact the project coordinator of Dataport. So just give me 1 second and I will share my screen. Okay, so I'm going to present briefly the project, and I will be introducing my colleagues who are going to provide demos in this session of Dataports. Okay. We will appreciate if you have any questions, you can put it in the system. So we will be checking those at the end of the session and try to have a questions and answers slot. Okay. So for the moment, I will provide a brief introductions and introduce my colleagues that are going to provide details about the platform that we are developing in Dataports. Okay. So first of all, I would like to set up a little bit of context of what we are talking about. So if you are thinking on European seaports, which is an infrastructure that may be familiar to you, uh, there is a huge number of going to focus on the platform, which has been released summer this year as a major outcome of the project. I'm going to give you some headlines of the different components, and for some of them, you're going to have complete details in today's session, okay? So just very brief, you have here at the bottom of the screen the data sources and the raw data that they're going to use. So this can be shared directly to this data access component, or if you plan to share your data directly in chain in the blockchain network of Dataports, you may have it. You have the access here thanks to this component. So the data access component in this case will help you to retrieve your data and will ease you the way to have your data inside the platform. Then we have the semantic interoperability, which will provide a common schema of the data for all the ports entities that are inside the ecosystem, and will give you tools to transfer this data to the common schema. Then we have the data abstraction and virtualization, where you will store your data and will be able to make preliminary transformation to your data needed probably for the analytic services for creating your artificial intelligence models, for example. All of this is what we call the data processing services. Then we have our data governance services. This is a technology that you are going to see right after my presentation, and it relies on a blockchain network, on Hyperledger Fabric, and we have here the clearing house for having all the logs of the platform, the IDS broker when you may have have a catalog of the metadata that is available in the Dataports ecosystem. Then you have the identity management with the authentication authorization mechanisms, data governance rules, where data providers and data owners can specify who can access the data, for which purpose, during which time. Any restriction you may can be handled here through smart contracts. Okay, that would be the data governance services, and then the analytics services that are the ones that will help you to create models, so you can later on deploy to applications regarding situational awareness, predictions, forecastings of what's happening, okay, in the port. And on the top of the platform, to communicate with the outside world, we have the platform service gateway. So if you are outside your trusted environment, your trusted organizations, you may use of the IDS connector we're using here, the data space connector, which is published by Fraunhofer recently, okay? So I will not extend more, and we wanted to show you today the data ports in action, so how this going to work at the end. Presentations are going to be short, about 9-10 minutes, and hopefully we will have at the end a brief panel discussion if we have time enough, with questions and answers from the audience. We will be checking the system of the Q&A. So if you have any question, please write down there. We will start with the data governance services that will be presented by Alexandros. Then we'll go through the data access and semantic interoperability that will be carried out by Andreu. The third session will be about the data abstraction and virtualization by Achilleas, and we will finish with the analytics services by my colleague Miguel. Okay, so so thanks very much. I'm giving room now to Alexandros. So please, you can take over control of the screen and start this set of demos of the data ports in action. Thanks.
Hello. Hopefully you can all see my screen and also me.
Perfect.
My name is Alexandros Zelidis. I'm a software engineer at CERT, the Center for Research and Technology Hellas, which is in Greece. And in the next 10 minutes, we're going to take a look at the data governance component of the Dataports platform. Here we see the diagram of the Dataports platform shown in the introduction, highlighting the data governance services. Data governance is a mechanism that enables the enforcement of access rules to business data assets in a transparent, verifiable, and non-reputable way. Data governance increases the consistency and confidence of the in the registered data, all the while ensuring data sovereignty, and is based on three pillars: appropriate people. So, for example, a hierarchy of a chief data officer, a data governance manager, data stewards, and so on. Appropriate technology, for example, blockchain technology, and appropriate processes, for example, for data definition, discovery, and so on. Given these, data governance can provide data ownership, accessibility, security, quality, and the ability to easily extract knowledge. Sorry. Um, the technologies used in building our data governance component are shown here. We have a blockchain network based on Hyperledger Fabric. We're using the Fabric SDK for Node.js to expose our services. The ledger state database is CouchDB, and we write our chain code, our smart contracts in Golang. The data governance component follows the Hyperledger Fabric architecture model. We have a channel for data governance in which two ports are participating, the Port of Valencia and the Port of Thessaloniki. Both ports participate by having a peer on the channel and by each providing their own certificate authority and their own order node. Other organizations, for example, data providers, data consumers, can also interact with the network through a well-defined API, which the peers expose. The network can be extended with more peers joining the channel in the case that new ports would join the consortium. Now, participants in the Dataports ecosystem can interact with the blockchain to perform any of these actions. So, for example, they can upload metadata of a dataset. They can define access rights to a dataset, search for datasets, request access to existing datasets. Providers can revoke access to a dataset, and they can also view the audit log of registration and access to datasets. And the diagram shows the hierarchy of these of the components used to build data governance. So on the bottom, there's the Hyperledger Fabric component with the chain code and the ledger. Then we have the middleware, which is built, as I said, with Node.js, which provides a REST API. And then we have a front end with which the users can interact and upload the metadata and define rules and so on. Finally, to end this 10 minutes presentation on data governance, I will show you a demo in which you're going to see the network and channel creation, the organization creation by the network provider, the organization administrator creation also by the network provider, the organization user creation by the organization administrator, an addition of a dataset in data governance, an access request on this dataset, and the acceptance of this request. So, without further ado, I'm going to start now the demo.
In this video, we're going to show how the data governance network is created and put to use. Setting up the network is done through shell scripts. First, the necessary certificate authorities are created, and then certificates are created for the admins and peers. Then comes starting the channel, creating the various peers, joining them to the channel, and so on. We then proceed to run the front-end web server. The view switches to show our front-end application, with the network administrator logging in. The network administrator proceeds to register a new organization, THPA, and its admin, Jane Doe. He adds all relevant organizational information and also the organization administrator's information, and proceeds to hit register. He then checks that the organization was indeed created and continues with the creation of the second participant organization, VPF. Again, the relevant information is entered for the organization and its admin, John Doe. And the administrator again presses register. He proceeds to click on the organization users to check that the new admin is present in the list of organization users. The network admin then logs off, and the VPF admin logs in with the credentials created by the network admin. She proceeds to change the password as obliged, and then goes to internal datasets, that is the datasets she owns, to upload a new dataset. In the metadata dashboard, she must fill in the required fields, marked by an asterisk, as well as any optional field she desires. By setting the access rights, she defines the rights that other users can ask for. Once all the metadata is entered, the admin submits the form. She then continues to select the newly created dataset from the list and looks at the details of the dataset, any permissions given for this dataset, its changes history, etc. Then the VPF admin logs out. Next, the THPA admin logs in and changes his password, as was the case with the VPF administrator. He views his organization's information, its registered users, and proceeds to register a new user for the THPA organization. He then views the internal datasets dashboard, which is empty, and decides to upload a new dataset. And submits the dataset. Once submitted, the admin checks that the dataset has been successfully added. The THPA admin then accesses the external dataset and sees that he is not authorized to access any external datasets. He does a search for datasets that belong to the VPF port authority. He chooses the dataset he finds and creates an access request. The available access rights for the specified dataset are read, write, and share, but the THPA admin requests only read and write permissions. And then logs out. The VPF admin logs in once more. He accesses the notifications menu, in which there is an access request from the THPA admin. She clicks on it and proceeds to accept it, being the data owner. So the request from the notifications menu is removed. Following, the VPF admin logs out and the THPA admin logs in again. He accesses the external datasets menu, where he views that he has been granted access to the VPF dataset by the VPF admin. He opens the Details tab, in which the metadata of the dataset are displayed. Finally, he logs out again. Now the video shows the THP admin logging in again. In reality, between logging out and logging in again, the system has been set up to contain multiple datasets, with permissions to each one having already been granted. So the THP admin accesses the internal datasets menu, he opens the details of a dataset, and views the permissions he granted for that specific dataset. Then he moves to the external datasets menu, he opens an external dataset, and views the permissions he's got for that specific dataset. That concludes our video presentation of the global data governance scenario.
And that's all from me. Thank you very much for your attention.
Good morning. My name is Andreu. I'm a researcher from the Universitat Politécnica of Valencia, and I'm going to show you the presentation about the data access and the semantic interoperability component of the Datapost platform. From the service perspective of the Datapost platform, the data access component and the semantic interoperability component are located inside the data processing services building blocks of the platform. These data processing services are exchanging data and metadata with the data governance services and with the analytics services of the platform. As an introduction, the data access component is basically a web-based tool to manage and run actions that integrates data into the Datapost platform. And the semantic interoperability component provides a common API and a data model to access to the available data and metadata of the Datapost platform. The data access component is the lowest layer of the Datapost platform and is the component in charge of interacting with the raw data to facilitate and the data sources to facilitate the access to their raw data. This task is responsibility of the agents who are in charge of accessing to these data sources and converting into data models understood by data ports. In addition, this data access component offers a data access manager who manages the agents, who interacts with the API to run and stop the agents and manage all the information of the agents, to obtain logs about the events that happens in this part, or to create new, or to use a SDK to create new agents. The other component, the semantic interoperability component, acts as a middleware layer between the data access component and the upper layers of the platform. This component provides a common API and data model to provide access to the available data and metadata in a common format. And there are mainly two ways to access to the data. The first one is based in subscriptions, and the second one is focused in make queries to receive historical or near real-time data. Finally, this is the metadata registry, where we can obtain the metadata of the data sources available in the platform. From a technological point of view, there are several technologies selected to implement these two components, and some of them are specifically developed for the project. For example, the Data Access Manager user interface, the Data Access Manager API, or the on-demand component. But it's important to highlight the selection of the Orion Context Broker as core component of these two components, because this Orion Context Broker mainly offers alignment with the Connecting Europa Facility Digital Program. We can take use of the ETSI NGSA LD API for right-time digital twin data exchange. Now we are using the version 2 of this NGSA standard, but we are migrating to the linked data format, and we are going to move from the Orion Context Broker to Orion LD Broker. And finally, we are following and we are aiming to collaborate with the Smart Data Models Initiative for the description of data models. And now I'm going to present these two components in action in a brief demo. The aim is access to several data sources. For example, here we have the PCEs who provides information, in this case, of the Port of Valencia. Let me show you in English, about vessels, port calls, status. For example, we can consider other data sources like weather APIs to access to information of the weather or like dark sky. For that reason, this component can integrate and provide an interoperability API to access to these data sources. For that reason, here we have the manager of the agents, and the first functionality interesting is that this component lets you to create a new agent. Create a new agent implies to select the data source and the kind of data source, if you are going to access to an API, a local TXT file, an MQTT listener. And this set of possible types are going to be extended in the future. After that, you can select the type of agent. It could be under subscription or on demand. And the data model. Here, we are providing two examples, like a data model related with weather of the PCS. After that, you can provide technical details, for example, the URL of the API where you are accessing, the broker API, and select the entities, the attributes of the data model that you are going to create an agent. Then, if you push here and complete the fields, you can download a code that in few steps you can complete and have an agent. Here in this screen, you have some image of agents created using this template and Dockerized, ready to be used. For example, as I said before, there are two kinds of agents, public subscribe or on demand. Public subscribe are agents that are sending information via subscription all the time, and for that reason I'm running, or on demand that are waiting for a query in order to start, provide information, and stop. For example, here we can show in this screen the instance of two agents. One of these is running and sending information related with weather, and the other related with the PCS, who is waiting for be started. I'm going to start it. The agent starts, and then this agent sends the current information of the Port of Valencia. For example, here you can see the PCS real-time agent and who has sent the information of different vessels at this moment and following the data format. For example, in the other kind of agent that is related with the weather, it has been run during an hour and it's sending information each 5 minutes. For example, here you can see that these weather agents, sorry for that. Well, I'm going to provide an example here. This weather agent is sending information about measures in a location, about the pressure, humidity, and it is sending this information each 5 minutes. Fine. Here is all this screen is related with the management of agents. But if you want to know the metadata that you have available, you have this screen, and you can inspect the different data sources available in your platform, the data model of these data sources, and a short description. This is the metadata registry that is available to know the different data models that you have available in the platform. If you push here, you can see the Git repository who stores the data model of these entities stored in the platform. And finally, you can see the subscriptions that you have active in the platform. And for example, here there is one subscription that is registering the changes of the departure of the status of the vessels in the port of Valencia, for example. Sorry, okay. This is the manager of the agents and the data sources available in the platform, but you can access to it using an API, for example, to access to on-demand information or subscription information. In order to show how it works, we have created an example application that can receive, for example, in this case, notifications to these data sources. And for example, when a vessel changes its status, it is notified in this application. Or maybe you can do queries to obtain the current status of these data sources, for example, the current status of the PCS data at this moment in the port, or to retrieve historical queries that in different periods of time, you can perform a query and obtain all the information. In this case, not only the vessels that are now in the ports, finished vessels that are authorized, operational, you can receive all the information of all the events of the port. And the same happens with the weather, because you can obtain the information of one sensor, the sensor who is sending information, or you can receive historical information of the sensors. And you can manage all the information of your organization using this API and, for example, a tool like this one. And this is the brief demonstration of my component. And if you have any question, I can respond you after the presentations. Thank you very much to everyone.
You're muted, Achilles.
Hello, my name is Achilles Marinakis, and I am a research engineer in the Institute of Communication and Computer Systems associated with the National Technical University of Athens. In this presentation, I will highlight the next component of the Dataports platform called data abstraction and virtualization. The scope of this component is to correctly prepare all the dataset that were shown before in order to have the proper quality to be used by the analytics services in order to provide the cognitive application that a Dataport offers. It also maintains useful metadata of these datasets, such as non-values, outlier percentages, and wrong values. And finally, exports those cleaned datasets to any possible recipient through RESTful APIs, focusing on quality of service attributes such as performance. So the overall goal of this component is to define mechanism in order to facilitate data management and data virtualization. Regarding the position of data abstraction and virtualization component in the overall Dataports platform, this component is part of the data processing services that the platform provides to the applications. In this picture is depicted the interconnection of the component with the other layers of the platform. As my colleague Andreu mentioned before, the component receives data from the semantic interoperability layer and the on-demand component in order to make its own processing and clean the data, filter the data, and finally expose them to the analytic services layer, which will be presented in the next presentation. Regarding the technological stack, the component is consists of 3 subcomponents. The first one is the processing and filtering software, paths, that it is developed using Python programming language and all the necessary package. The next one is the virtual data repository, the VDR, which uses MongoDB as a database framework, where we apply replication techniques and auto-scaling mechanisms in order to further improve the performance of the system. And finally, the virtual data container, which performs the final processing and transformation of the data, again, developed using Python programming language. Last but not least, in order to optimize the management of all the containers, the component lives within a Kubernetes cluster. After this short presentation, a brief demo will follow, where we will see how the component pre-processes 2 different kinds of data sets, and we will have a look at the generated metadata CSV files. After storing the clean data to the virtual data repository, then we will make real-time requests through the virtual data container in order to retrieve those data. So I will move now to the live demonstration. For that reason, I will use the Jupyter Notebook. I will run the commands in order to run in the parallel while I am explaining the functionality of the component. Well, as I said before, we will see how the component pre-process and cleans the data using 2 different data sets, one from the Valencia port community system data, which mainly contains categorical values, and one containing a Greek weather data, mostly dealing with numerical values. It is worth noting that our component is a generic one and can easily handles different kind of data with being semi-structured or structured. So I have triggered the command, and we see here the metadata regarding the Valencia port community system dataset. We can see here that we found some non-values, or here we see some wrong values, applying the rule that meaning that the departure timestamp cannot be before the arrival one regarding a specific vessel. So with this mechanism, we ensure that only cleaned and right values are being installed in the platform and being analyzed furthermore in order to produce AI services. And regarding the other dataset, the Greek weather dataset, we see here, for example, outlier detection, non-values detection, and again, we apply some logical rules in order to find out some wrong values. So, having stored in our virtual data repository the preprocessed and clean datasets, now we will make a real-time request to those datasets in order to retrieve a portion of those data, a data point, based on some specific value parameters. For that reason, we have developed three different methods. For example, I will now use the first one, according to which we retrieve all the data, all the weather data regarding a specific year, in this case 2010. So I'm giving the request here, and what we will see as output is that all the data that appear here refer to this specific year defined by the user. I will try another method also. Here we will see, for example, how the outlier detection is working. For example, in this last row, we can see that the component detected an outlier regarding the average wind speed, and if we can investigate in the actual value here, yes, we can indeed see that it is an outlier value to be taken into account from the analytic services component in order to improve the quality of the cognitive applications. So this concludes the live demo and also the presentation. Thank you very much for your attention, and I am happy to answer any possible questions. Thank you.
Let me take control. Hello, everyone. I hope you can hear me properly and see my screen. My name is Miguel Bravo. I am from ITI, from Valencia. I am in charge of the development of the automatic model training engine component, which is within the analytics services umbrella. Yeah.
We cannot see your screen.
You cannot?
We cannot.
All right. Give me a second, please. I hope you can see it now.
Now it's okay. Yeah.
Okay. Thank you very much for the information. So you didn't miss anything, by the way. So I will continue where I was talking about. That's what I said before. What I did was to develop, we are in charge of developing the component called Automatic Models Training Engine, which is exactly located here in under the umbrella of the analytics services. And regarding the architecture and technologies of our components, first of all, I would like to say that this component is mainly focused on the development of cognitive services, and in order to, by using machine learning algorithms and data management techniques. So that's the main goal of the component. And for that, this is the architecture we designed and implemented so far, as long as the technology is used for each of the parts. So the component basically is structured in the following way, where we take the data in a Parquet format files from the data abstraction and virtualization component. It will go to a distributed data repository implemented in Hadoop, in HDFS. There is a subcomponent called machine learning pipelines, which will take the data from the repository previously mentioned in order to analyze, manage, prepare, and use the data for training machine learning models. For that, we use scikit-learn, Prophet, PyTorch, Flatin, and StatsModels library, common known libraries. And then those machine learning pipelines are implemented in the so-called distributed training engine subcomponent, which is supported by ITI proprietary development called Radiatus, which is a big data analytics as a service developed, as I said, by ITI. It will use Dask in the background in order to distribute not only the data but the training models also. After that, and on top of that, we have a third subcomponent called Training Web Interface, which I will show you afterwards at the end of the presentation as part of the demonstration, where the user, the potential user, will be able to interact with a component from the outside by using the IDS broker metadata. Once the machine learning models have been trained, the best one is selected, and it will be selected for the cognitive service, which will be available for the outside user to make potential predictions. Talking about the cognitive services, we developed so far the 6 cognitive services shown here. I will not go into the detail of all of them, of course, but I will talk about some of them in order to give you a brief idea of what we mean by cognitive services. For instance, all of them, of course, are related to ports, are port-oriented cognitive services. The first of them is the so-called Bessel time of departure estimator. It takes the real historical data from the ports in order to make a time series prediction, an estimation of when a potential vessel coming to a specific port or terminal will depart in the future. The second one is the vessel port cost calculator. It will estimate, again, the number or the amount of vessel calls in a certain port along Europe. Or for instance, we have different services for predicting the amount of imports or exports of a specific product, which will go to a port of international port, European port, or coming to a specific port also. So it's a wide range of different cognitive services using data from ports. Behind the cognitive services, it exists the subcomponent previously mentioned called machine learning pipeline. This is the machine learning pipeline I was talking before, and what it does basically is take the data, prepare it, make some transformations, make a deep feature selection, and then the set of machine learning models I will tell you afterwards. Both standard machine learning and deep learning models, all of them based on time series, because that's the data we are dealing with in data ports. Afterwards, the user can also, or the pipeline can also make a models optimization by performing a hyperparameter tuning technique. And finally, the best model along all of them will be selected for the cognitive service. We will somehow have a best prediction possible. Talking about the algorithms of machine learning implemented here, you can see a brief introduction to some of them. As I said before, all of them are oriented to time series. Sarimax, statistical algorithms, Prophet, LSTMs, support vector regressors, etc. The user will also have the opportunity to configure the machine learning pipeline in different ways, in 4 different ways exactly: a fast pipeline, a fast training, get a model very fast, a standard training by using most of the steps of the machine learning pipeline, the optimum strategy, which will perform a model's optimization, and a deep strategy, which will use deep learning models, which of course will take the much more time than the other previous strategies. And as you can imagine, they are more complex models. Usually we will get quite good predictions, but will take much more time. And finally, I'm going to go to the demonstration of the web interface previously mentioned, as I promised before, which is this one over here. This is the web interface the user will have the opportunity to interact with in order to play with the component. In the first screen, we can see a list of already trained cognitive services. This is the name of the cognitive service trained, the description, when it was trained, and the status of it. If it's stopped, if it's a running service, or if it's a training cognitive service. The user will have the option to deploy it, to stop it, to get more information, to delete it. So it will have this versatility in order to interact with the component. This is the list of cognitive services. I'm going to show you how to create a new one. Here, the user will select the create label over here, and it will first of all set a proper name for the cognitive service. So in this case, we can type, for instance, data ports BDVA service. And the description, for instance, we're going to train one of the 6 already implemented cognitive services. We can implement the average vessel birth time, for instance. So, for instance, we will say average vessel birth time service 1 week prediction. That's what we want to try to train with the wizard. So we select the cognitive service previously mentioned. In the second stage, the user will have the opportunity to select which dataset they desire to use. We have data from Valencia port, marine traffic from Barcelona, and other places, other ports from Spain in this case. Let's try with Valencia port, for instance, and we can see the metadata over here, the description, a number of variables, route count, the size, and the last update of the dataset. So we will click next. In this specific service, the user will have a different specific configuration. The configuration of the service will start with a selection of desired port. In Valencia, we have 3 different ports, Valencia, Sagunt, and Gandia. In this case, we select Valencia. We also can select a terminal as a user, specific terminal, for instance, this one over here, and the time granularity of the service. So how much time ahead we will have the prediction. In this case, we said 1 week, so we will select 1 week in this case, and consider only the last year of training because it improves usually the predictions. Set configuration, and then we have to, as a user, choose the strategy desired. In this case, we want an optimum strategy because we want the best model possible. And finally, we will set a train service with the configuration parameters selected before. And as you can see, we have the service the user selected with the training status. So once trained, it will be ready here to be developed and make predictions. This is the end of my presentations. Thank you very much. If you have any question, please type it down in your systems.
Okay, thank you very much, Miguel, and all the presenters. So please, if all of you can switch on your camera for this final part of the meeting. So we have like 5 minutes left for our slot. And I would like to go through the questions from the audience. Okay, so we have one from Amin and Joshua. Hope I pronounced well the surname. And it goes after Alexandro's presentation. So he asked, could you please elaborate on how the off-chain data is shared? Is the requester allowed to download it? So please, Alexandros, if you can take this question?
Yes, thank you for the question. Yes, once the requester becomes a consumer, meaning once the request has been accepted by the provider, then he can request the data by using an IDS connector. The IDS connector contains an endpoint, which is given and maintained by the provider. And the connector checks the permissions that checks with data governance about the permissions that the consumer has on that dataset. And if everything checks out, informs the provider, who then enables the connection, and the consumer is able to download the dataset. I hope this answers the question.
I think so. Thank you, Alexandros. So as we have time, one more question. It's for Miguel in the last presentation. So if we have a different port than the ones that are in the consortium of data ports for Valencia and Thessaloniki, can they use these cognitive services? How easy is to use these cognitive services that you have been sold?
Hello, thank you for the question. Very interesting question, by the way. Yes, the question is the answer is yes. Any port from Europe would be could use the cognitive services implemented, as long as the data, the structure of the data is similar to the one we used. So the data will be aligned, will have to be aligned with the structure decided by and implemented by data ports. In that case, any of the cognitive services showed will be available for them to be used. Thank you very much.
Okay, thank you, Miguel. And Andreu, regarding this common data schema, so how does it going to work when the platform is completely available next year? So could you give us some views on this?
Regarding this common schema is going to be provided in a Git repository internal in the project, and it will be the data ports common data model. And now we are defining it with the use cases of the project. And our idea is, once we finish it and we have, how to say it, a stable version of this data model, start to collaborate with other initiatives in order to integrate this common schema with other projects. The aim of this schema is when we create the agents that we have explained, you can select this part of data model, and when you are taking the information from a data source and converting to this common data model, you have the parameters that you need to use as target to convert your information.
Okay, thank you, Andreu. And last question for Achilleas. So you show us 3 transformations needed to process the data. So are you planning to have more inside the project? Are you going to make this available in the platform? You are muted, Achilleas.
Thank you, Santiago, for the question. Yes, we're planning to develop even more methods in order to provide different data points to potential data consumers. But that will be happen depending on the data sets that we will have. We will investigate them. We will go through them, and given the requirements that we will have from the end users, we will develop those methods in order to provide the needed data to the data consumers.
Okay, thank you very much, Achilleas. So with this round of questions and answers, we can finish this session today. I hope for all the audience it has been interesting. You can visit our webpage where you will find all the information, our development portal also. You have there the emails of the people that we have been presenting today. So thanks to the presenters, and yeah, see you next time, and keep in touch if you are interested. Okay, thank you very much.
Thanks very much.
Thank you.
Goodbye.
Thank you. Bye.
Bye.
Ciao.
Good day. Welcome to a session, Data Vaults, the road to a trusted personal data space. I will be the host of the session. My name is Yuri Glickman. I'm a researcher at Fraunhofer Focus. And together with my colleagues from the Data Vaults project, we are organizing this session for you. And at the end of the session, we will be glad to answer your questions. So please let me share my screen so we could start. Okay. Wonderful. As you can guess from the name, the session is dedicated to personal data platforms, and Data Vaults, it's one of the projects which is developing such a platform. So I already quickly introduced myself. So I'm a researcher from Berlin in Germany, and I'm a deputy head of the Department of Digital Public Services, specialized on support of public, European and German, especially public administration in their modernization with help of IT technology. And our special focus is on data platforms. We are developing many data platforms, especially for open data, or managing data and personal data. And this is my main research interest, I would say. And I'm coordinator of Data Vaults project, which I will present today. And I'm not alone. I have three my colleagues from the project, with Vincent Koenen from Endemant 7, CEO of Endemant 7, an innovative SME in Belgium. Paolo Boscolo. Paolo is the IT director of Comune di Prato in Italy. And Sotirios Kousouris, managing director of a Suite 5 SME innovative company. And he is also a technical leader of Data Vaults project. So we all will make a short presentations, and we will reserve some time for discussion at the end of answering your questions. So my role here is just to give you a short overview of the project, what it's all about, and what are we trying to achieve. As I'm the coordinator, and our project started in 2020 in January, and will continue until end of the next month. We are quite a big project. It's one of the projects funded by the European Commission on the ICT 13 topic, supporting the emergence of data markets and the data economy. We are quite a big consortium. As you can see on the right side of the slides, we have quite big corporations in our consortium, and many well-known research organizations, and many innovative SMEs. We have a very good partner supporting us on legal and ethics issues. It's ETA Consulting. And we have 5 very interesting demonstrators, and at the same time, data providers. 2 of them will be speaking today and will present their plans and what we are doing. And I will just give you now a quick overview about them. So the first one, it's a sport club, Olympiacos. For sure, you know Olympiacos. It's well known in many sport arts, like football or basketball or many others. And this is our partner on sports and activity personal data demonstrator. We have a municipality of Piraeus, which is one of the biggest, or maybe even biggest European ports in Greece. We have Endemant 7. Vincent will talk today, and Endemant 7, it's a very interesting, innovative company producing interesting product. Another demonstrator is dedicated smart energy and smart energy data with MIW Energia company, also in our SME, this time from Spain. And finally, but not last, it's Prato municipality. Paula will present to the personal data for municipal services and the tourism industry pilot scenarios. So what it's all about, it's about sharing personal and not necessarily personal, but data coming from individuals. And we all know it's a fast growing market. And there is a huge interest from the companies because they want to know their customers. And there are a lot of drawbacks on this way for individuals to start sharing their data. But the reality is we are already all sharing our data, and we are sharing our data more and more with every day because we are consuming services from big companies. And at the moment, control over data is mostly by big companies. And there are a lot of types of data which we are sharing, and we are not even always aware about that, or not so, let's say, explicitly aware. Of course, we agreed to conditions what we are sharing data, and maybe from a legislative point of view, everything is all right. But usually people even don't read what we agree when we're subscribing to a certain electronic service, or when we're installing an app for getting bonus points in the supermarket or something. And now it's, at least in Germany, it's becoming more and more popular. Almost every chain in German supermarket networks, we have own applications, which is monitoring what you are buying, who you are, when you go to the supermarket. And you can imagine how much data we're collecting about you, and we know your profile and who you are. So, and of course, all these also make a lot of concerns by people. Many of them, they understand certain risks which could come if someone criminal could get access to this data, or corporations misuse this data. And I feel a certain lack of control. And it's very difficult for a private person to understand all these risks. And at the same time, we're getting some services, we're sharing data, but not explicitly. And when a certain researcher or someone comes to them and asks to share their data, we're afraid to do it. So it's important to let them know what actually sharing is happening already, and what by sharing the information which we already shared to big corporation, we could help to the city or to certain another non-profit organization, maybe to improve the quality of services. And maybe we could share this data in another way without disclosing their personality, without disclosing really personal data, but disclosing kind of anonymized or pseudonymized data. There is a huge lack of trust on that. And we did, well, we started from one of the important things. We ran a study with the citizens to find out what is actually their attitude to data sharing. And we found out what actually there is no such a great willingness, what is understandable, but it's kind of neutral thinking about sharing, but there are a lot of thinking about dangers. So we would like to have more control. We would prefer to share just anonymized data. We are not actually so much know about compensation mechanisms. It does not necessarily need to be money. It could be a certain interesting service. So sometimes we like to support community or support certain interesting movements. So people actually more tend to share their data for such purpose than for getting some small cents for their data. And of course, they don't want to be too busy with sharing their data. It should be a simple process. And they would like to have a certain automatisms, but with their control. So they could trust this mechanism and at the same time don't spend too much time on sharing data. So what we want to offer them? So we want to offer them, and to you, of course, to give you control and offer you a solution for which you could share the data with whom you will, how you will, and under conditions which you define. So this is important. And our offer, it's a platform, so which covers such a flow, starting from collecting data, which is already a challenge, and to providing insights to you or maybe to target also consumer of your data. And of course, it's everything under control of individual users. So where everything starts from collection of data, we have many sources. It's difficult to collect data, and we are providing a convenient tool based on Fraunhofer open source development called Pivot Consus. We are using this tool, which enables us to collect data from different sources. And this data is coming to Personal Data Vault, which is in a kind of a mobile application, or it's application in the personal cloud of a user, where data is stored and where a user can control the data, make aggregation, and make already certain pseudonymization or anonymization of this data. And then a user can decide what kind of data the user wants to share through a kind of a market which we offer. And this is a cloud data vault platform where a certain analysis of data can be done and where trusted and secure sharing is enabled. And we are using a lot of security technologies starting from TPM attestation. We are using attribute-based access control and attribute-based encryption. We are using searchable encryption. And of course, we are using layered anonymization. And the user can define with whom a user wants to share, under which conditions, and for how long. And data seeker can make an offer. And thanks to blockchain technology, which we are using, we are realizing smart contracts between the user and data seeker in order to enable them to trade data. And we are also providing the mechanism and working on providing new mechanisms to give a value back from data seeker to individual providers. So this is a very important point, and my colleague Sotiris will talk, I think, about this aspect and its importance in the last presentation of the session. And data seeker gets insights and also can share this insights back with individual users or use this insights in their business. So this is important. And of course, we need to be in the legal and ethics framework. This is one of the important aspects in our project, and we've spent on it a lot of time. And you can read our report where we did a very detailed analysis on the legal and ethics framework in Europe on national and European level. So here's I think I don't have so much time. Here's a quick overview of what actually we have in our platform. We did a mapping of our architecture to standardize the pipeline coming from a database project, which is which is providing recommendations how to map what other research projects are doing to a kind of standard data value chain. And here you can see there are 4 main steps: data acquisition, data storage, analytics, machine learning, and action, interaction, visualization, access. So 4 different colors are used to show what kind of components in our architecture associated with which part of the data value chain. So everything started from data fetcher, which collects data. After that, data comes to personal asset store, where it could be anonymized and where user can define access policies. Then on the third step, analytics engine can be used on the third step to analyze data, and when sharing configuration, where user can define how the data can be shared and which conditions.
Trials or distributed or decentralized clinical trials, and then real world data collection, PROs, and so on. These are new needs from the pharma industry. So what we did at Andaman 7 is create a solution that tries to address these various modes of needs or problems, It's composed of a patient-facing mobile application, which is free for all patients. As I said, it's a personal health record. So it's a way to store all of your data, but we store it only on the smartphone. There is nothing stored in the cloud. And beside that, we have a platform that allows to exchange data after patient consent. There's always patient consent. And then if the platform is used, then the exchange of data is peer-to-peer. So that means that it, of course, uses the internet, but it doesn't store any data in the cloud by default. I say by default because when we will come to data vaults, you will see that the way of operation is a bit different, but this is the basic Andamant 7 application and platform outside of the data vault system. So by default, the patients store their data on their smartphone and only on their smartphone, and nobody has access to that data except the patient, not even us as a company. What does it look like? It looks like, I went too fast, sorry. It looks like a simple application. So you can see on the left side that you can store information about your drugs, documents, consultations, information, allergies, previous conditions. You can see on the middle screen that you can have images and documents, in this case PDF, but it could be Word or text files. And on the right side, you can see that you can manage more than one health record. For example, your children's record or your parents if they are older and they are not comfortable managing their data themselves. But it's more than a personal health record. It's also a tool to coordinate work with hospitals. So in this case, you see a new icon under the red arrow, which is expanded on the two screens on the right side. And there you can see that there is a special, we call it dashboard if you want, for the patients with a specific condition. In this case, it's coagulation problem. A blood condition, and there are a number of drugs that are specific to that or that can interact with that, and there's also some test results which are important. One of them is called INR, like you can see on the bottom right. And so in these two screens, what we do is collect all of the data that is important, whether it's a medication, a lab test result, or another condition, or anything that is important for that condition. We also provide questionnaires, so doctors can ask questions to patients and patients can answer to doctors. And then, as you can see on the middle screen, there's a help section there where there are documents and possibly videos and other training materials that are provided, for example, by doctors or others, that will then be available to patients and only to the patient with that specific condition. So you see here that we can very easily fine-tune the application to some conditions so that it's really adapted to the condition. This is an example of another use case where it's more about a clinical trial. So here the middle screen shows, the middle and right screen show a simple questionnaire that the patients first have to consent. So the patient consent to being part of the study. And then when they have consented, they receive electronic questionnaires like this, which they can either fill in manually or data can be grabbed from their personal health record and shared with a research agency or institution. Of course, data is anonymized in all of those cases. That's the law. Right, so but that means that the patients that collect their data from their hospitals, from their labs, or from other mobile apps can store everything in their personal health record and then use that to contribute to research. So in a sense, if I need to summarize the Andamant 7 platform still outside of the Data Vault initiative, is that what we're trying to do is to help patients, empower patients, giving them access to their data, all of their data, without any conditions. And GDPR goes in that direction, as you know, but also patients' laws, patient rights laws. Then we try to help manage disease. That's with the care industry, doctors, hospitals, and so on. And then we help to evaluate the outcomes of new drugs and so on for the pharma industry. And all of that with one unique platform and for all conditions. So we are not specialized in diabetes or cancer or heart problems, we can manage all of them together on the same platform. Now, why are we interested in the Data Vaults platform, and what do we plan to do there? Well, as you know, Data Vaults is as Yuri explained, is a global platform for any type of data about citizen. And we take care, if you want, of a subset of those data, which are the health data. And so we speak as much about patients as citizens, but still, we are focused on that special type of data, and that's a very specific type of data, as you know. It's probably more critical or more sensible, or no, I should say sensitive, sorry, type of data. So Andaman 7 will be the health data demonstrator for the Data Vaults platform. What we hope to contribute and to get out of those projects is that to provide to patients more ways to contribute to research. So beside our own systems to contribute to research, if patients upload their data to first their personal data vault, then the cloud data vault, and make their data available in anonymized format, mostly to others, that's going to open up the ways patients can contribute to research. And we have seen studies where 85% of patients agree, of course, under some conditions, to share their data. And that's without being paid also. So there's a lot of empathy in patients, and they agree to share their data as long as they have some control. And then another element that we hope will be useful in that project is the reverse. So if data comes in my data vault store, personal vault from other sources, I would like to keep them and bring them back to my local mobile phone so that I can have control over that anytime, including when I don't have any connection to the internet, because Andaman 7 works even if you're not connected to the internet, since all the data is offline. And then finally, what we also hope to contribute is the specific elements about security and privacy that are related to health data. And voilà, I finished 5 seconds early. Yuri, I hope you'll be happy with the timing.
Thank you, Vincent, for this very interesting presentation. So our next speaker is Paolo Boscolo from Municipality di Prato, from Comune di Prato. And to participants of the session, I invite you to leave your questions, if you have any, to Vincent, me, or our presenters in the chat. Paolo?
Okay, can you see my screen? Just a second.
You need to switch between, yes. Make it full.
Okay. It's okay now?
Yes.
So I will be very quick because I'm Paolo Boscolo. I'm working for the Prato City Council here in Italy, and we are involved in the project just as a pilot site. So we would like to test the possible usage of the platform that will be offered by the project in our context, which is our context. So we will try to use the platform in 3 possible ways. The first one is related to the policy concerning mobility in the mobility area, and which is the scope of the scenario of this pilot. We, of course, use to make policies in mobility, we need data. All these policies are based on data. We normally use probes, we use surveys or other information like that in order to modify our mobility plan. So data are very important. What would we like to do with the platform is to use the platform to collect data from users, directly from the users. And this is a different scenario respect to what is happening now, where data are normally sold as by third parties. So what we hope is to offer to our office the possibility to use the platform to make analytics on this data provided by the users, and so on these analytics to find a better way to move around the city. what we have done till now is we have identified, of course, the pilot scenario. We have contributed to the technical requirement for the platform. We have analyzed all the privacy issues coming from the usage of this platform, and of course, identifying the KPI to evaluate the success of the experiment. And we have involved, of course, the Office of the Administration that is in charge of mobility problems. The second usage of the platform is very similar to the previous one, but is related to the cultural and touristic issues of the city. The city is a city close to Florence, so we have problem in promoting the city for tourism because we have a bigger city, a most important city near to us, but the tourism is something that is increasing also in our city. It's a medieval city. And we have also the problem of promoting the cultural event in the city. So again, to do that, data are always important because we need to know which are the preferences of the people, how the people participated in previous event, which are their impression about what happened in the city, etc., etc. So again, we have involved our office in charge for cultural planning in the city and for tourism planning. And we have identified the story, the technical requirement, involved the city, administration office, and we have found a way, like in the previous experiment, to involve citizens in this pilot in order to see how they can react in the usage by the usage of the platform. But we have also another third kind of experiment we would like to do with the platform, that is related to the problem of distributing the certified information that the City Council manages on behalf of the user, because of the law that is mandatory telling us to do that. For example, the certificates. The population registry produce a lot of certificates that the citizen use to demonstrate something toward third parties. You know, there is also a European principle of the once only, is the once only principle that oblige us as a public administration to avoid to ask many times citizens about information we already have. So what we are trying to do with the platform is something different to respect the management of big data, huge data set, but we are trying to use the possibility for the platform to keep in the user space very sensitive information like certificates, and to use the platform to show this sensitive information to the third users, the third party that are interested at the moment they are interested. So we will try to connect the Data Vault platform to our population registry and use the platform to download constantly the updated version of the certificates that are maintained in the platform. And I could say it's something similar to the Andaman application, where the data are the personal data concerning medication, radiography, and so on. In this case, we are dealing with certificates, and for different purpose, of course. And also in this case, we have involved the city council offices that are in charge of that. And we are trying to involve a third party that is a typical institution that is asking for certificates when citizens go there. In particular, the center that helps citizens in fiscal procedures to the tax declaration or things like that. But which is the point of view of a local authority, particularly here in Italy, respect the Data Vault proposal? Of course, there are many kinds of considerations. The first kind is the business model. In other presentation, I found a very interesting observation concerning how currently the market of data is organized. And of course, it looks like a colonialism or monopoly situation now, because in particular, as a public administration, even if we are managing our citizens, and so we are able to collect, if necessary, data from them, for some policies, we are now obliged to ask this data to a third party that is making business with them. It seems very strange. So Data Vault can help us to move to a data sovereignty situation where the flow of this data is completely different. and it can generate advantages for everyone in a win-win situation. Because in fact, the Data Vaults is trying to offer also a mechanism through which the citizen that offer data to the platform in order to be provided to a third party, let's say the public administration, in this case, in our pilot cases, he will receive back a remuneration for that. That is not the case now. The users of the platform that collect data are just receiving a service that is considered by the citizen equivalent to the value of the data they provide to the manager of these services. It's not always true. Of course, because we can have a direct contact with our citizen when we are asking data from them, we can have a more detailed and more targeted data collection activity. And so this can lead to a better policy in our city. Other consideration concerning business is the sustainability of this scheme. We are trying to analyze in the project how a platform like that can be operated. In which way? There will be a company that will operate it, or it could be used by any administration wanting to deal with the citizen, with citizen data. And so the public administration could be, for example, the operator of the platform that can offer to the citizen this platform and be a sort of broker of data also toward third party. So other kind of a consideration, the privacy. Of course, a platform like that can offer, because of the technologies that are used inside, better privacy preservation for citizens. And there are a lot of mechanisms of explicit consent where the citizen has to say yes every time some third party is wanting to use and exploit the data he has provided to the platform. That is also not true at the moment, because when you say to Google, you can use my data, you say yes for everything normally, or no, you are not interested to see which kind we are added condition, you say yes, and that's all. And there are also other technologies like anonymization and the creation of personas that can allow the third party interested in usage data, in using the data, to use them in a very anonymous way, or in a way they cannot relate the data to the person that owns this data. So it's another way to increase the privacy of citizens. And the next point is important in the context of a public administration. In case the public administration uses a platform like that, and in particular, in the case of the administration using the platform as the operator of the platform, what is created is a stronger relation between the administration and the citizen. And the citizen can see the administration as a sort of grantor in the exploitation of the data toward the third party. And this can create local business, of course, respect the situation now where the business is managed completely by multinational companies. So this is also an interesting point to be discussed. And GDPR. GDPR is affecting a lot of our activity, and also the platform, the data platform, the Data Vault is affected by DAME, by these law regulations, and we are trying to see how we can suggest a better implementation of a GDPR, and how we can use the GDPR rule inside the platform in order they are comfortable for users. For example, we can say that probably the GDPR rules are not adequate for some kind of data collection, in particular when we are able to collect anonymous or data associated to generic personas, so not personal data. Why it is so necessary that to use the very complicated procedure foreseen by the GDPR about the consensus and things like that. We need to think a little bit about that. So the bureaucracy around the GDPR and the privacy need to be analyzed and simplified if possible. So the platform, the Data Vault platform, is trying to offer tools to test also this and to try a different way to achieve that. So I think I have finished. I hope to have provided an overview of what we are trying to do as a public administration with the data platform, and we will see at the end of the project about the results that we hope that will be very, very interesting. Thank you.
Thank you, Paolo. And everybody is welcome to ask questions, Paolo, in the chat, and hopefully we we will have some time left at the end also to answer them, or Paolo will answer them directly in the chat. So our next speaker is Sotiris Kousouris, Managing Director of Suite5. Sotiris.
Hey, thank you, Yuri, and thanks to all the previous presenters. So this will be the last presentation of this session, and I will try to shed some light on the key technologies that could be used and should be invested in for personal data spaces, but those more or less are also technologies that could apply to other kind of data spaces. In this case, we have personal data, which are more or less a bit more sensitive and have some peculiarities that call for different handling in some ways. So, as I say, as Yuri introduced me, I'm Sotiris. I'm working in the Data Vaults project, having, let's say, the main technology responsibility. And my area of expertise is more or less on data analytics and AI, and actually data-driven technologies. So I'm by profession, I'm a computer and software engineer. And in this project, we're trying actually to bring forward, as you may have guessed by the title of this session and by what was explained previously by the different speakers, a kind of a mini personal data space or an experimental approach towards a personal data space. So this is essentially what Data Vaults is. You can see it as a data marketplace that actually brings together data owners and data seekers. On the one hand, we have infrastructure that we call personal app, so software and infrastructure that resides at the end of the data owner to collect and push their data to a platform, a cloud-based platform, which is essentially the core point of this data space. And in this actual quest and in this journey, all these 2 years, we learned a lot. And our presentation, our last presentation, will actually try to highlight quite briefly what could be done and which are the key points that one has to consider when he would like to provide such a solution as a personal data space. So the first thing that we learned is that sourcing data and collecting data and extracting data in order to be used is a great challenge. We'll talk about all these 5 bullets in a while. The second one is that in such a data space, and especially because it concerns personal data, trust and security is of utmost importance. Moreover, there should be compliance with the legislation. It's something that is quite critical. It's imperative to be there, and it's actually something that is necessary. And then also there is a need to actually provide a very good UX. I'm not talking about UI, I will explain the difference, and explainability to the users of such a solution in order to gain audience and not lose it. And finally, there is, of course, a key question that applies to all data space of how is data valued, and not necessarily in monetary terms, but also in other dimensions, in order to actually be able to provide the incentives to different users to utilize such platforms, come on board and actually take part in this sharing ecosystem. So we're going to talk a little bit about where we can find the data and how we can get it. And this is a core problem for any data space. However, when we are talking about personal data spaces, this is quite bigger. We are not talking about data getting, drilled, let's say, out of some systems or out of just a single environment, which could be the case of an industrial data space. But we're talking about data that is produced by an individual. So we have one entity that is producing the raw data, but many different stakeholders that are actually getting this data, enriching this data. And in this process, what they do is that they use different types, data types, they use different structures, and they use different parts of the data and generate, of course, different insights. One would argue that that's okay because we are having now in Europe some regulations where you can get back your data, and such stakeholders are actually in a place where they should not, keep your data away from you. However, when you really try to do that in reality, you see that you just get different types of fruit. So I'm paraphrasing then when life gives you lemons quote here. So there are no standardized data schemes. There are no standardized APIs to retrieve this data, and there are constant changes in how such operators provide this data. They make it quite hard for people and for other companies to get this data. And at the end, what you get is you get different parts and variants of same data. So even if it's, let's say, activity data, you will get it in different structures, different types. So as the image here suggests, green apples, red apples, and so on. So what we need here is that, first of all, we need to have some smart ways of fetching this data and support the schemes of authorizing once, but retrieve constantly from different data providers. So I authorized my data to be downloaded, and this is done constantly as I produce the data. And of course, we need to have some new ways and tools using also state-of-the-art structures that are out there to enrich this data, transform them, and link them in formats that could be universally used by anyone. So apart from the data sourcing question, there are also quite big questions about trust and security. This is, as you can understand, highly important for personal data spaces. Trust matters, and it is a very big portion of the success of such platforms. So those platforms need to be trusted, first of all, by their users. They should clearly denote how they treat the data, how they control the data, and they also need to provide the necessary technology and trust and reliability guarantees. You need to know that you trust the system you're providing the data, and also the system needs to trust the user as well. So the users need to be identifiable, their devices probably should be authenticated, and there should be checks in order to see that the data that they're offloading there is actually authentic data, is non-tampered with, and cannot be used for any malicious activity or any activity that falls out of the scopes of such data space. So the technologies that should be used and where the focus should be when it comes to trust are on things like attestation rules and methods, on smart methods for on-premise or cloud-based data availability and analysis, and for managing identity in a trusted and universal way. So there are out there many different systems that do that. There are also European identity management providers like IDEAS or so. So there needs to be, a way to actually be able to authenticate and verify the correct identity of such users. However, trust is not the only part that is essential here, but it's also security. And this is actually a key thing because we're talking about data sharing. So one needs to be able to trust that his data are actually secured and are delivered to the anticipated and intended recipients in a way that cannot be, let's say, sniffed or whatever by intermediaries or other parties. So there needs to be ways to make this data secure, but yet have them discoverable and computable in order to not to restrain the potential of such a data space. And of course, there need to be flexible access control mechanisms in order to refrain from having one-on-one relationships between how data is permissions are provided for accessing the data, but work on different schemes that allow much broader and flexible access control methods, however, without losing the control at the end. So the technologies that are there, which have been also meant by Yuri in the beginning, have to do with things like attribute-based encryption, searchable encryption, and even we can go to things like functional or homomorphic encryption. And there are also quite many robust access control schemes like attribute-based encryption and so on. Nevertheless, though that all those technologies are there, they're coming, most of them out of the crypto world, there are also many challenges to overcome. And the thing here is that those technologies have been produced actually without having in mind certain specifics that data spaces have, like the amount of data, or like the velocity and the volume of the data you would like to encrypt, for example, or decrypt. And such stuff actually, stuff are actually the ones that impose certain limitations. So if you would like to go into in the direction of searchable encryption, you might end up with non-performance systems. Or if you're working and thinking about applying functional encryption to some of your data, then you need to think very good in which parts of the data you should use it, because you cannot use it for any type you would like. So all these technologies are here to help. Nevertheless, more research is needed, and this is because we need to actually bridge the world of data science and data management with the world of crypto operations in order to make all those technologies actually performant, trusted, and fitting to the context of data spaces. Of course, it's not only about security and trust, but it's also about compliance and auditing of what is being done with the data. So Yuri talked a little bit about the legal and ethical framework that we have been building in DataVaults. That's a huge work. And it's true that actually compliance and evidence-based audits are things that can actually increase the overall trust of a platform. So there needs to be compliance both with regulations, but also with things like licensing and IPR things. And what is also important, and it's a thing that is not tackled at the moment by data spaces, and it's quite hard to be tackled, to be frank, is how you can have auditable trails of the whole data lifecycle from the beginning of data generation to the usage of the platform. Also able to cover, to the extent this is possible, of off-platform usage of those kind of data. So there could be methods to be, there are methods to be employed to solve those problems or parts of those problems. We talked about GDPR compliant and IPR respective frameworks that have to be there and should be considered during the design time of the different services. Services should be built on those requirements. There are novel approaches that have to do with distributed ledgers and blockchain that could actually help a lot in writing down and documenting in an immutable manner how operations are performed, like data sharing, access controls, and so on. And one could also think about smart methods for the hybrid dataset composition in order to limit, for example, off-platform usage, meaning that you can, for example, get 90% of the dataset and use it offline, but the 10% that is also crucial and you will need this should come always from an online source that you cannot access outside of the platform, and so on. But this, again, is something that is quite experimental. Further research needs to be done in those directions, but those are things that should be actually greatly considered. So I also talked about user experience, which is quite crucial for such platforms. And this is actually not UI, not how things should look, and that they should look nice and pleasing, which is a big plus, but also to work with the underlying structure of how a user is experiencing his journey over such a platform. You need to have something that is solid and robust in order not to provide at the end a very complex platform and scare users away, but actually to retain the users on the platform and make them want to use it. So as you all know, we're talking here about concepts like privacy, trust, which are quite hard to follow, and having all those options and all those check boxes and drop-down lists to actually satisfy those requirements in platforms are actually things that discourage users. Most of the users, we have to think that will be not of a very high level of IT literacy. And of course, this would mean they would not be able to understand such things. So we need actually services that could convey in a smart way the necessary messages and the most important info, which has to do with privacy, security, and how those are used in the platform, and delivering them to the users on a mainstream level, allowing, of course, all the advanced users to use extra features that are provided by the platform. And of course, what is highly important is to take advantage of the devices or that people already use, or take advantage on the ways that people access the internet and could access such platforms. So most of the people do it through their smartphones. So whatever we build should be more or less operating through a smartphone. You should not have the user actually working on another device that he's not comfortable. So I'm trying to sum up. The last and big question here is about how one defines the value of the data, which is a huge question. Actually, it's very difficult to set a price on the data, and it's very difficult to understand how a data asset is generating value in the secondary market or in products and services they use it. So what we need is that we need to offer to users tools and methods that could actually track the value of the data sets that they offer and the value that those generate. And of course, also to find ways to give them motives to share more data, because we're not talking about monetary compensation here, but also of social value that could be accompanying this data, and they should be, triggered to utilize such platforms, share more for the common good. So this is my last slide. I hope I'll finish on time. So all those data spaces are actually mountains that somebody needs to climb in order to, deliver something. So this is a picture of Mount Olympus in Greece. It's the top of this mountain. And if somebody would like to reach there, it's a very tough trail. And the same tough trail is also for personal data spaces. So we need to actually invest more in research and in standardization in domains that have to do with data models, with crypto and trust operation, and of course with UX, making legislation more and compliance more understandable to users. And in this quest, what is also needed is the support by the European Commission and of the different member states in order to actually have directives to impose that such standards and methods are to be used by any data processor to make things more interoperable, more user-friendly, and actually give back to the community a big part and portion of the value that they enjoy by processing all this data. So that will be all from my side, and thank you very much. I'm giving the floor back to Yuri now. I don't know if we have time for any question, or I just...
Thank you, Satiris, for presentation. Unfortunately, actually, we don't have any time for questions. I think now it's 12:30, but maybe we could answer quickly one or two. One was, maybe you could answer it as technical leader. It's about main differences of data vaults to the pods in a Solid project, which was inspired or initiated by Tim Berners-Lee. If you know, if not, I could answer. If you prefer me to answer.
Yeah, Yuri, it's breaking up on my side, so maybe you answer.
Okay, so the difference, of course, we have a different approach compared to Solid, which is a very interesting initiative on semantic web technology for data sharing. I would call it like that. In our case, we are cover the full data value flow, starting from data collection, which is a huge challenge itself, and we also have data trading, and we are relying more on blockchain technology for smart contracts and data sharing. So we are a bit different, I think. So I don't know if Solid is using blockchain. I don't think so. But truth speaking, I don't know this side of. But the main difference is for sure what our scope is a bit wider when by them. So this is definitely a difference. Okay. I saw also another question in the chat. One moment. From Rigo Wenning, do you use policy for data use limitations while sharing? Which is to use series, or this is just until ACL triggers and then out of control? We have done rights labeling beyond ACL in a special project. Special, it's the name of the project.
Yeah, I could answer to that quite fast because now you know I can hear it. I was writing about that. Actually, in Data Vaults, what we do is that we apply policies to the at the time when data is to be shared between from a user to the platform, and those actual policies are there and are imposed by the blockchain when somebody would like to get the data. But those are more or less policies that have to do with access to the data, and they describe how usage shall be done, though those are not imposed over the platform. So once somebody can take the data and download it, then it's out of control of the Data Vaults platform.
Okay. I don't see more questions. Maybe for I saw what Rigo is from W3C, so maybe it's interesting. We're also using W3C technologies, and we are our data model it's a profile of DCAT, which we are extending in order to satisfy our needs for the categorizing data and categorizing data. And we are developing special profile which would cover our needs for sharing personal data. So very welcome, and would like to exchange with anyone who is interested in the topic. Okay, thank you very much for joining our session. I hope it was interesting for you. The slides will be published by the organizers, and of course this video, I guess. Thank you, and I wish you other interesting sessions at this event.
Okay, so hello everybody. I'm here to present a national space data initiative, and I'm very happy to have this opportunity. My name is Ann-Kristin Eriksson. I work at RISE since a couple of years, and I work as research program manager, amongst other things, with this National Space Data Lab initiative. It concerns Earth observation data. And my background is in this geographical information system since before RISE. And I also have a medtech and telecom background. And my plan for today looks like this. I will start to say some introductory about why we are doing this, what are we doing, why now, what are the enablers, and in the end I will summarize what we mean by this National Space Data Lab of Sweden that we are doing together with our partners. So let's go. So the needs. We all know that a lot of things are happening with the globe, and there are increasing needs for keeping track of environmental changes. And this can be done by Earth observation data and with the satellite missions up there. And the use cases are very wide, but it could be about climate adaptation, it could be about forestry, about growth, water levels, and so on. And we all know also that we have this Agenda 2030 about sustainability in the world. So lots of use of the Earth observation data. And to be able to use the data, we need innovation hubs, and we need efficient innovation hubs. So therefore, our mission in this surrounding is to make the world more sustainable, and doing this by implementing a knowledge and data hub for our observation data, and then apply AI and other methods to this big data, and look at the trends, look at changes in the environment, and give decision makers support for their decisions. So that is our mission. And we also see we have this European strategy for data, and it will be implemented in national strategies for data. And this is right on spot as well for this mission. So why now? And what are the enablers as it looks now? Well, for the first, the space industry is growing tremendously, and the data is exploding. This is a little bit of old picture. It ends 2015, but it gives the idea how the data is exploding, the available data from satellite missions out there. And if we just look at the European Space Agency, we in this initiative, we are mainly focusing on Copernicus program, and I will tell you a little bit more about that. But that is not the only program only for ESA. You have the science missions and you have the weather related missions as well. But for us, we have started to use the Copernicus data. And this is the next enabler. It's the world's largest program for daily collection of space data. And maybe the most important thing is that it's a long-term commitment from the European Space Agency, and it's full, free, and open access to data. The idea here, and as it is long-term, stakeholders then can have the courage to invest in this for a long term. on forward. In our initiative here in Sweden, we have been so far, since the start, 2019, we started with this initiative, we have been looking at the Sentinel-1, 2, and 3. And the Copernicus program continues to deliver. So we have Sentinel-5 pollution, for example, and so on. And again, just a summary, this is from the Copernicus messages that it's climate change, it's marine, it's land monitoring, and it's also emergency management as examples. So the use cases are very wide. As this is very, very big data, you need compute power and capability to handle all these data. So what is included then in our initiative is that we tailor the data for Sweden and the region up here in the north of Sweden, North Scandinavia, the Baltic Sea. We have a data center at RISE in Luleå, in the northern of Sweden, very close to Esrange and other kind of the space industry stakeholders in Sweden. And the data center we use now is a very energy effective data center. And just to say, that's a lot of data centers in the area. For example, we are just a couple of kilometers from the Facebook data center site in Europe. And the reason for choosing this area for the data centers is, for example, that the river close by, the Luleå River, is giving 15% around that of all the production of energy in the whole country. So we are in a good place. Also, when you have this compute power, you need concepts to structure the data and to ensure the quality. And I'll give you some examples now of some of these concepts that we have used so far. First of all, the concept from Australia called Open Data Cube. It's developed by the Australian geoscience community, and it's used in the Australian Data Cube, or what we call now the Space Data Lab. It has been used by Swiss Data Cube and their initiative in their country, also Digital of Africa, Brazil, and now we are using it. And a short kind of popular description of what is Open Data Cube. You can see that as you have a map, and then you add time, giving you this cube. Or you have this map, you have frequency bands, like in Sentinel-2. You add different frequency bands. What is the value here? Well, it helps you organize the data, and doing it from various satellites. It gives you the opportunity to use Python, which is a very popular library. And you can easily make time series analysis on this big data of Earth observation. And you can also connect it to some of the key software, commercial software already out there, and integrate it. What we're looking at right now this autumn is Open Earth Observation, a quite new concept. And it's also defining an interface between the infrastructure, the platform, and front-end applications. So these we are implementing as we speak. And also there is a concept called Stack. And the Stack concept also makes the assets searchable and make it easier to use the data. And as I said from the beginning, you need methods to analyze the data. And at RISE, we have a lot of AI capacity. This is the RISE network picture I stole from them, just showing all the areas that RISE is included. And RISE, I hope I said that from the beginning, but it's the Research Institute of Sweden. And we are in a lot of areas and wide areas. So these round circles here about built environment, climate change, and so on, is that what we see is related to this National Space Data Lab initiative. And then you need partners. You need to cooperate. It's complex. We live in a complex world and we need to cooperate. And we have done cooperation by having a tight dialogue with the use case owners. And we have developing this platform for Earth observation, what we call now Space Data Lab, together with a lot of use case owners. So we have been running, I think it's 10 pilot cases, proof of concept cases up until now. And this is a picture, just a summary of some of the partners. Up in the left corner, you have the 4 partners from the beginning. So we also have AI Sweden as a strong AI competence organization. We have the National Space Agency here, and also the Space University in Sweden, Luleå University of Technology. So these are the 4 initiative stakeholders driving the first project from 2019. And then we have all these use case owners, and this is just a picture of Swedish authorities working with forest or with properties or with agriculture and things like that. So it's about 15 in this community that needs Copernicus data. It's called the Copernicus Corporation in Sweden. And then we have the enablers that I talked about, and also, of course, we need funding for this. And Vinnova has been a very important part funding this. We are also part of the EU project where RISE is the only Swedish partner that is called European Hub for Data, the Federation of Data-Driven Innovation Hubs. And here we offer space data to the SMEs that could search for funding for experiments. I just listened to a new appointed professor at the Space University here in Luleå. So I stole this picture where he kind of presented connecting topics and network of partners from the Luleå University perspective. So I just wanted to show you that. I mean, we have S-Range, there's space corporation companies, and they invest a lot, Luleå Technical University, to have programs in this area. And we are here. The RISE site I work at is here in the north of Sweden. See, and this is also a picture for where we have these orbital launch sites. So it feels good to be very close to the S-Range site. Okay, so I'll try to summarize what are we doing then? We could call it Digital Earth of Sweden, or Digital Earth of Northern Scandinavia, Baltic Sea, or Space Data Lab as the name is now. But to summarize, we use the Copernicus data. We have strong compute power and storage. We use these concepts. We add AI, and in the future also other data sets for data fusion to give the decision makers decision support, for example, in the climate adaptation area. I forgot to say that I was supposed to say that you should put your questions in stage 1 chat, and then I will have it in the Zoom chat. And I will save a couple of minutes in the end for your questions. So please put it in the stage 1 chat of the event web. again, a summary. To make the world more sustainable, we think that the Space Data Lab, in connection with all other European and global space data labs, is something very, very valuable here. And last but not least, there has been a governmental assignment just a couple of weeks ago, where the government has said to the Space Agency, okay, look at what could be done very long term in this area. So that is ongoing now for this Space Data Lab. And it's again the reasons that the government of Sweden see is this sustainability goals and also the European data strategy goal. There is a landing page. It's under development, but it's already there. It's spacedatalab.se. Here you can find information about the ecosystem, the partners. You can find short information about all the pilot projects that has been going on up until now. And take a look if you're curious about this. So a couple of minutes left for questions. Sorry for forgetting to mention the stage 1 part in the beginning. So you can also, if you'd like, you can just shout out if you have any questions or comments, or you can contact me afterwards in the event structure, or you have my contact information and email on this page. So please reach out if you're interested. And thanks for having me here at this final event. So yeah, I'm reading a chat here. So let's see, I can kind of conclude. The conclusion is that we are going to continue this journey. We now have the governmental request to look overall from a national perspective. And I think the Space Agency of Sweden are going to give their report in March next year. And I can also add that we are cooperating a bit, or have started a cooperation with the Finnish Data Lab, because we want to have the Baltic Sea a part of this data tailored for this region. So that cooperation has started as well. I didn't have that on the screen. But it's so much fun to work with this. We are a team of people here at RISE together with the people of the other partners, and it's very interesting, and the users are very keen on having everything ready yesterday. So it's great to work with this. Okay. Okay, so thanks. That was my conclusion. Thanks again for having me here.
Hello, everyone. This is Javier from Atos, a representative of Atos on the unit of Atos Research and Innovation, the unit of blockchain identity and privacy. And today we would like to present you on our session the Kraken project that we are coordinating. And the Kraken stands for User Engagement with Privacy-Preserving Data Sharing Platforms. And today we would like to share with you an introduction of our pillars on Kraken project, and also try to discuss or try to get some feedback from you on the challenges and opportunities. Let me go to the workshop objectives that we have today, because we would like to structure a little bit this workshop, this hour. So as I mentioned, we would like to address some challenges and opportunities that we have on our technologies. And for that, we would like to present the 3 pillars that we have in our project. First pillar is the cryptographic methods that is going to support the privacy preserving analytics. So for that, we have our expert, Sebastian Ramacher, from Austrian Institute of Technology. Also, we are going to see the second pillar is the self-sovereign identity. And then we are going to talk about the marketplace that is our, let's say, our core platform that we have also in the project. Then the fourth slot, it's to evaluate these results that we have to share with you the evaluation of that we have in our first pilot round. So for that's the agenda that we propose, as I mentioned, the 3 pillars presented by the crypto methods. It's going to be presented by Sebastian Ramacher. He's a scientist on the Austrian Institute of Technology. Also the marketplace presented by Davide Accanini from Linkeus, managing director of Linkeus, and also the self-sovereign identity paradigm, the pillar that is going to be presented by Ángel Palomares from Atos, senior researcher on blockchain identity and privacy unit. And then after these 3 pillars that is going to give you and provide you a big overview of our project, we are going to give the floor to Silvia, a senior researcher from Fondazione Bruno Kessner company, and we are going to present the evaluation, as I mentioned, the evaluation results that we have in the first round of our pilots. Another thing that we would like to have with this session is to try to engage more users. So feel free to get in contact with us. At the end of the project, I'm going to share some content details of our project. So I'm going to give the floor for the main pillars to Sebastian.
Yeah, hi, my name is Sebastian Ramacher. As already said by Javier, I'm a scientist at the Austrian Institute of Technology here in Vienna, and I'm working on different parts of cryptography, from post-quantum crypto to privacy-preserving crypto. That is the focus of Kraken. Next slide, please. So in Kraken, what we want to achieve with the cryptographic pillar is that we assume that we have multiple users that produce data sets from including personal data, maybe e-health data, educational data. And there's an interested party, for example, a research organization that wants to compute statistics on multiple data sets. For example, you could consider, right, there's a lot of, you have hospitals with a lot of data on e-health data, and then you want to run a study over all hospitals in Europe, let's say, then you want to combine that. There's, of course, a challenge regarding privacy here. So we want to build an architecture that preserves privacy. So we want to have a privacy by design architecture. So essentially what we want to achieve is that the buyer only really sees the result without the original data. And in the cryptographic literature, we know of secure multi-party computation, which is a technology that supports this kind of computations. in short, secure multi-party computations is a family of protocols that allows multiple parties to jointly compute on their data, which means that they learn together the result of the computation, but nobody of the involved parties learns any of the individual bits. So the main important thing is that the inputs stay private, but they can arrive at a combined result of the computation. Next slide, please. So we build our marketplace architecture that Davide will later describe in detail based on this multi-party computation approach. So the idea is that we first have a user with their data. They produce shares, which are encrypted to some computation nodes that are then sent via the marketplace to these nodes, and they can then compute results for some research organization or an interested buyer. Next slide. So with this method, we achieve privacy, but there's of course another challenge, right? As a user, I might want to control what my data is used for. So what we envision here is that a user is able to define a certain set of functions or a certain set of statistics which are allowed to be performed on their data. This can be, for example, done, right? The user assigns kind of a set of possible functions or statistics and sends this to also the marketplace. And the computations nodes are then need to verify that the user actually allows some certain kind of computation. So we can also limit the use to what the user allows, and then we have a third challenge, right? The buyer wants, of course, to be sure that the computation result that he gets is authentic. So the third pillar that we have to build here is some authenticity guarantees, and for that, next slide, please. We leverage zero-knowledge proofs. Zero-knowledge proofs are a cryptographic primitive that allow you to prove statements of some that they are valid, but without revealing some secret bits. This can be done for mathematical puzzles or also secret information like private keys, but also, of course, with respect to encrypted data. Next slide, please. So what we do here is that the MPC nodes, besides performing the computation, they also verify the signatures as before, but they also, next slide, please. Or next, yeah, they also generate the proof that they verified the data and the data was authentic, that the data is coming from the user. So you get a chain of authenticity from the user to the buyer. Yeah, and with that, we achieve all three features, right? We have privacy of the data from the users. The buyer only gets the result. The user can limit the computations to what they want to allow. And we have authenticity from the user to the buyer so that the buyer is sure that this is the actual result that he gets. And with that, I'll give back to Javier.
Yes, let me check if we have our partner also connected. Well, unfortunately, technical problems, we don't have Davide, so I'm going to give the floor to the next pillar, Angel, if you want to share your screen.
Yes, could you, okay. Can you see my screen?
Yes.
Excellent. Well, I'm Angel Palomares. I'm working for Atos in the project mainly to do support or working on the self-sovereign identity pillar. And before to introduce what we are doing, I would like to give you a main idea what is a self-sovereign identity and where it's come from. At the end of the day, self-sovereign identity is just an identity management system. And well, to give you an idea, normally when we have identity management, the end user identify to identity provider, and then with the information, if the identity provider say that, all right, I trust this guy, you can go then use my system. Well, with the time, this kind of systems need to improve or make it bigger, and same identity provider can provide services to different service providers. That is what is called a single sign-on. But even with that wasn't enough, and the system were evolution to provide a different identity providers that can provide service to provide an identity to different services. However, with the population of using of blockchain technology, we have a new paradigm that we can apply to this normal stage of the how to identify an end user. The idea here will be then that if we introduce on the equation a layer where we can rely on, then the identity provider is not needed anymore. We are going to change the paradigm from a centralized system to a decentralized system. And therefore, the end user will be put on the center of the screen of the board and will be the one who obtains the information and where we are going to rely to obtain the information. In order to do so, when the end user tries to connect to a service provider, it's going to use the layer that we have underlined in order to guarantee that he's who claims to be. However, we can say, all right, but how the end user is not faking his information? Well, the idea will be that obtain the information from an authority that then is going to allow us to give the verified credential that we need to trust on that this user is who claims to be. Once we have done this, and I would like to highlight here that the end user will be in the center on the board, as I said before. So it will be the main actor, and we pass from a centralized system where this identity provider contains the information about the identity of the end user. Now is the end user who has the information on his mobile device or in any other system, right? Well, once I say so, let me say, for instance, one specific case where we have used this paradigm in Kraken. For instance, we are using for obtaining a diploma. In this case, a student can go to university to obtain his diploma. And once he obtained an issue credential or a verified credential issued by the university, he can present a proof to other parties to say, okay, I have this degree and I cannot withdraw it. And then we can use all the services based on the verified credential that I have present before. That will be one specific case that we are using. Right, but how we have tackled this problem from the development point of view? We have been focused, first of all, on producing a component that the end user can use, in this case, using a mobile application, using a wallet that the end user can obtain his information within his mobile and then provide it to the verifiers. But also we have developed some mechanisms to other service providers like university or other marketplace or any other service provider to easy them to adopt this kind of a self-sovereign identity solution. In this case, we have produced a component we call Ledger User Broker. Right. Here we can see more details. This is more, let's say, low-level detail diagram where you can see all the different components that we are going to use for applying this kind of solution. And well, here I can highlight you what I said before, the mobile application, but also the Ledger User Broker. And other thing that I would like to highlight is that in our particular case, we are going to go one step further than other possible solution, and it's that we are going to use here a backup solution in case that the end user can lose his mobile or want to use multiple devices for this kind of self-sovereign identity solution. So the idea will be that the end user can have his verified credentials or his identity information in different devices. Right. With this, I would like to give you a short demo of what we are doing. For instance, in this particular case, the end user is going to try to connect to the marketplace, reading in this particular case a QR code to do the connection. We establishing a connection with the marketplace, and once we have this connection established, then the end user is going to be allowed to fill in a form for the registration. Here we can provide our data that we are going to include on the marketplace with the information required. And once we have done that, as you can see on the demo, the marketplace is sending an offer for issuing a credential. That means that the marketplace is telling to the end user, please, do you agree that we will send you this credential? And the end user is going to then receive that credential, store it in the mobile using the name that he desires for it. And once the end user has the credential, you can see here the content of the data that we have used. Right, now we have this information within the mobile. The end user can connect to the marketplace at any time, and using this credential can log in, as you can see here, to the system. And with this, I finish. That's it from my side.
Okay, thank you very much, Angel. If you can stop sharing, I'm going to share my screen again. And now we solve our problems on the technical side. So I think that we have Davide with us. So I will give the floor to Davide Zaccanini, our expert on the marketplace.
Thank you, Javier. Should I ask you to advance the slides, or should I share my screen?
If you want to share your screen, maybe it's better. So I can stop sharing my screen.
Let me do that. Here we go.
Okay, you can put in presentation mode and let's go.
All right. Well, thank you very much for attending this session. I'm Davide Zaccanini. I'm the managing director at Linkeos. We work on privacy preserving technologies in healthcare and other domains. And we are responsible for leading the implementation of the marketplace in the Kraken project. And what Angel just presented is a good segue into this aspect of our platform. As users are authenticated and identified the way Angel just explained, they gain access to, indeed, the marketplace. In essence, we're developing a system for people to not only share, but also monetize their personal data in a way that protects fully their privacy, and at the same time gives them the incentives to really participate in the data ecosystem. And we are deploying this solution in two main areas, healthcare and education. So people who want to share their personal health data from mobile apps and wearables, but also in future implementations, their electronic medical records, and also their academic records, so their diplomas, grades, and their academic history. So the motivation for doing all this is that, as we know, just by reading the newspapers, the data ecosystem is actually broken. Meaning, whether institutions or actual data subjects are engaging with people who want to use their data, we face the situation of systems that can control patient or students' data, but at the same time, they're not the owners of these data. And they may have some consent to use the data, but there is a lot of gray area when it comes to deciding exactly what the patients or the students really stated in their consent. Those who actually own the data have no physical way of controlling them because they're just not part of the IT
ecosystem. The information technology ecosystem basically doesn't give them any real way of engaging with their own data and those who want to use them. At the same time, IT companies do control data flows, and they are those in the best position to really regulate the data access, but they are not really the legal owners of the data, nor they are those who receive consent to use the data, which are instead the hospitals and the universities for these two specific data we're dealing with. So it's a fragmented system where there is really no clear value chain that could be followed when at the end of it, somebody would like to buy or access the data. So what we're doing is in Kraken is really bringing coherence to the value chain and de-risking data monetization activities. Now, speaking about data monetization, this is in many environments still a bit of a dirty word. The current situation is such that if you think about really assigning financial value to data, you are probably stepping into a minefield of privacy and security and ethical liabilities. And rightfully so, because indeed, if you're not able to protect the privacy of the data subjects, then data monetization becomes really a contentious type of proposition. What we are doing in Kraken is to make that proposition actually consistent with both legal and ethical principles. And we're doing that by not only aligning the interests of all the subjects in the value chain, so hospital and universities, patients and students, and the IT companies that manage their data, and finally the data users, but also making sure that as we protect privacy at every step of the value chain, the friction between monetizing data and protecting the personal information of the data subject is actually resolved. We are able, with our technologies, to really decouple the two sides of this value chain, the private information and the financial gains that subjects can obtain if they are willing to share that information. So we are able to offer incentives and to mitigate the risks for all the stakeholders in ways that today's technology really make scalable and reliable. And we do that by bringing to the table a set of important infrastructures that in some cases are fully user-facing, such as our mobile apps, where users can set their permissions and really state who should access their data, for what purposes, for how long, and who should not. And this is a choice that we put entirely in the hands of data subjects, whether they're students or patients. With our mobile apps, they are in full control of who sees what in their personal information. And they can revoke these permissions at any time. This is a first important step. Without this, any kind of data monetization is really not legal or ethical, and therefore not viable as a value proposition. But this is not enough. Patient permissions in many jurisdictions are not enough to then exercise some kind of financial transaction on the underlying data, even if the patient is okay or willing to share his personal information. To do that, at least in many jurisdictions in Italy, in Europe, definitely Italy and other countries explicitly forbid the selling of personal information, even in presence of explicit consent. So in order to do that, what you need to do is to actually protect the information. And this is where secure multi-party computation comes to the forefront. Secure multi-party computation is a way of really stopping any personal information from leaking or being disclosed to whoever is using the data. And the way that secure multi-party computation does it is by encrypting and breaking down queries that are then ran onto a federated data system. And the result of these queries are only the aggregated results of the actual computation. Nothing regarding the underlying records is ever disclosed, so that on one side, whoever is accessing the data can perform complex computations, including the development of AI agents on the underlying data, but without ever revealing who the subjects are, what their characteristics are, or anything even indirectly related to their identities. All this is orchestrated by the blockchain, where the permissions that are set by the patients on our desktop and mobile apps are captured and computed, so that if the right type of user is asking access to the data, the blockchain can enforce access or deny it based on the specific policies and preferences that the user has expressed. Now, all this comes together in the marketplace. So the underlying technologies that I just explained allow users to go on a data catalog and look at what data are being made available by the users, in what form, for how long, and at what price. As the users log in the marketplace, the blockchain registers the type of requests that they're making and matches those requests with the permissions that have been set by the patients or the students using the patient consent app. At that point, if the request is granted and access is given, the computation triggers using the secure multi-party computation, which queries over the encrypted infrastructure, the databases of the hospitals or the universities. And the results are returned to the user, who only sees the aggregated statistics. With this infrastructure, we are able to offer to the users what is really an e-commerce environment where data are presented, described by the sellers, and priced, so that they can finally access the information in a private and secure way predictably, hopefully in the future, hundreds of different data sets, both in healthcare and educational environments. And with this, I finish my presentation. Thank you very much.
Thank you very much, Davide. You can stop sharing. I can share my screen again. Thank you. And we can continue with, because we swap these presentations, sorry for that. We can continue with Silvia. I'm going to give her the floor to present the evaluation results that we have during the first pilot round. Please, Silvia.
Yeah, thank you, Javier. I'm Silvia Gabrielli. I'm a senior researcher at Fondazione Bruno Kessler in Italy, and I'm an expert in human factors, human-computer interaction, and I'm currently working on the design of digital health solutions. Our role in Kraken is that of leading the evaluation activities related to the main pillars that have been presented by the previous speakers. And so you can go to the next slide. And so, yeah, I would like just to provide you some information, some key results from this first evaluation round that we conducted quite recently. It was in the last 2 months. And we are almost at the end of the second year of the project. So it was a good moment now for evaluating the first prototype release of the Kraken platform, where that includes, of course, the different components that have been presented by my colleagues. So in this presentation, I would like just to say some words about the main results we got. The main aims of our evaluation was, of course, to assess the level of usability of the prototype that we offered to the first users, early adopters of our platform, but also the aim were to investigate a little bit more other dimensions of the possible adoption of this solution by users. So we were interested, for example, to understand more about the user expectation for such a platform, an e-commerce platform that could be used to share personal data. We wanted to investigate a little bit more the preferences of users, of different kinds of users. We, of course, selected the key representatives of the target user groups that are most interesting for us in offering this solution, but also investigating some possible concerns that people might have in using such a platform, and of course the first prototype. So here I just listed some main steps of this of the preparation of this evaluation that we conducted. We decided to recruit some participants, and as Davide was saying, we are interested to test this solution in two main domains. One is the healthcare domain, and the other is for sharing educational data. And so we recruited about 12 users for the first pilot, for the health pilot, and 3 users that were students for the educational pilot. We collected the signed consent forms, and we asked these users to watch some short videos that were providing some introductions to the main components of the system. And then we provided instructions to access the platform, and we provided them a list of relevant tasks to be performed for each of these 2 pilot domains. To give you an example, for example, try to connect to the Kraken platform and try to register to the marketplace, to try to create a data product and to publish it, to set your privacy preferences, for example, and also try to access it to consume data, so to browse for interesting data that you would like to use. So these kind of tasks that users performed, and after interacting individually with this platform, they were asked to fill in an online form of the SUS questionnaire. It is the System Usability Scale questionnaire that is quite practical as a tool for understanding the level of usability that we could achieve with this first prototype, and to see if there were some main issues that should be fixed or should be improved. And then our users were involved in some workshops, so we conducted some collective interviews with them to understand more their preferences, concerns, and so on. In this slide, you see summarized some main characteristics of our participants. So for the health pilot, we involved 12 persons, 6 men, 6 women. They were quite balanced also in terms of age group involved. The majority was in the age group from 35 to 54, but we also had 2 users that were a little bit younger and 2 that were a little bit older, of course. Then you see the kind of expertise and occupation that they had. So 3 were researchers, 2 were big data for health experts, 2 were legal experts that are also important for assessing all the ethics and privacy issues in using such a platform. 1 was a blockchain expert, 2 were managers of companies that are providing digital health solutions, and 5 were project managers of public health solutions. So, as I was saying before, they were representatives of key target user groups for this platform. For the education pilot, we involved 3 students, 2 women and 1 man. Of course, they were in quite around the age of 25, from 18 to 34, and they were enrolled at the Technical University of Graz, and they had some computer science background. In this slide, you see summarized the results of the usability evaluation. So what came out from the SUS questionnaire, and you can see that for both pilots, we reached an average SUS score on the scale from 0 to 100. It was from 51.87 until 55. So this is considered a good, fair result. It is okay, let's say, for a first prototype. We, of course, we had released very quite recently this solution, and so there was a marginal acceptance of this solution. But we also found some possible areas of improvements, especially in the process of downloading, installing the mobile SSI app, and so on. So we are working, of course, on these kind of improvements. And here I would like to tell you something about the results of the workshops where we interviewed users regarding expectations, preferences, and concerns. So, for example, regarding the health pilot, our users were asked some questions on what they thought about the Kraken platform, if they thought they had developed some trust by using it and some interest in using this platform for sharing data products. So you see that 58% expressed trust and interest in using the platform, and they were both interested in providing or consuming data products by means of this solution. 42 had some concerns still regarding the privacy, the security, and the quality, especially of the data sharing. So for our users, data quality was very important. They really asked for Kraken to have to present and to guarantee that the personal data that are shared are reliable and accurate. And they think also that it's important that the platform ensures that usage of the data is compliant with the privacy settings and goals that are stated by the data provider. Okay, next slide. Then we had some questions that were investigating more if users were interested in using the privacy preserving analytics that can be offered by the platform, and if it was okay for them to use such a secure authentication method through the mobile app, the SSI app. And we found that 92% of the users were interested in using the privacy preserving analytics. They thought that this could be a very interesting service, providing added value to our platform. And some of them also expressed the preference for having very customizable analytics based on the latest crypto techniques. So this is very important for our colleagues that are working in this direction. And then 66% said that they agree to use the SSI mobile app to authenticate, because this is quite commonplace nowadays, or similar methods like SPID, for example, that can be used. Then some other questions were investigating the types of data that they would like to share, and also the entities with which they would like to share data. So most users would like to share anonymized data products, and preferably for research purposes. Of course, we had many researchers in our sample, so they were interested in this sense. And also the main factors that are affecting their willingness to share data are the purpose of the data usage, also ethics reasons. For example, they would like to share data for improving and to find new healthcare treatments that are important. They stress the importance of having a control of the data sharing, so the possibility of sharing this data, but also to revoke access to the data. So these features are very important for our system. And some others also mentioned the possibility of receiving credits or some forms of acknowledgement for the data sharing. So these were the main factors leading their decisions to share data. Then we had some questions regarding the compensation for users for sharing data products. And here you see a more balanced situation. 41% would be interested to receive monetary forms of compensation, but 41% would prefer non-monetary forms of compensation. For example, they mentioned access to possible health services. And But what is very important is 92% would find difficult to define a price for a data product that can be shared. So this is an important issue to consider. And in particular, all participants replied to us that they would appreciate to have a sort of support from the platform to define, or at least to check if the prices that they have set are okay, are fine. And also, we had some questions regarding their possible concerns with data protection and privacy that is ensured by Kraken. And here we had 83% that had not such clear how Kraken can ensure protection and privacy of data shared. For example, there were some of the people involved that had not much experience with blockchain technology, and so they asked for having more detailed information in this sense. And 66 thought that Kraken should try to minimize risk as much as possible. Of course, there is no platform that can be full, can guarantee no risk, but in some cases, they think that the important task is to minimize the risk as much as possible. And also 50% would prefer to have more information, for example, on the measures adopted by Kraken for ensuring privacy by design, and also to provide contextual support when the user is at the point of making key decisions in creating and sharing a data product. So in that case, they would need to be a little bit more supported by the platform to make the right choice and not to make any possible mistake. And for the education pilot, here we had, as I remind you, the 3 students that replied to our questions. And regarding trust and interest in Kraken, 2/3 would trust the platform, and they were interested in using such a platform for sharing education data. They also asked to have a very easy to use platform and functionalities, and so it's important for them to provide a very good level of user experience. And they thought that it was particularly needed, for example, when they are applying for a job, and this would allow them not to avoid sending printed documents. That is not an operation they really liked. So they thought it was very important. And regarding the privacy preserving analytics and the secure authentication method, for the first one, it was not so clear for them what this kind of feature functionalities, how much it could be useful for them. So they would like to read more and to understand more about this possible added value service. And they agreed to use the SSI mobile app to authenticate. They thought that once solved any usability problem, this could be very easy to use and quite straightforward for them to use. Then regarding the types of data to share and the entities to share data with, they were happy to share, for example, educational data like their CVs, the diplomas, also other types of data that are used in communication with government agencies and so on. They would be happy to share this information, especially with public institutions like university, but also with employers, with state agencies and the government. They were a little bit reluctant to share with private companies, especially if they know that the private companies are using this data for commercial purposes, so not for making money, let's say. Also, for what concerns the questions about compensation, all these participants would prefer non-monetary forms of compensation. For example, they mentioned free access to educational software licenses. And regarding the acceptance and concerns with data protection and privacy, all the participants said that they would not like to share with private companies that are storing data out of Europe. Some of them had concerns on possible change of regulations. So they were asking what happens once the Kraken project is over, if there is a discontinuity in managing the platform or the marketplace. So these were issues that came to their mind. And also they showed a sort of preference for a gradual system system adoption. They were saying, like, I would start to use the platform, maybe sharing less critical type of data, but then if everything is fine, I would trust this platform and use it also for our more personal data sharing. And here we have the conclusion. Of course, I've been very brief, but our next steps are, of course, these insights that we have collected from our users, even if the sample was not so large, were very important for considering their preferences and to continue to use a user-centered design approach in our project. So we would like to finalize the design of a platform, including additional features, functionalities that we can provide by taking into account this kind of feedback that users provided. And we would like to make also the improvements to the usability that were asked by our testers, initial testers. So in terms of the SUS scale, we would like to achieve at least a level of 68 for in the second round of evaluation, in order to have a very good interaction, very good usability, avoiding any problem with and frustration with using the platform. Then also we are planning to do a second evaluation round next year in 2022, and we would like to involve at least 35 more users for both these pilots, the healthcare and the educational one. So we are interested to maybe enlarge the invitation to more people that have expertise or interest in using our platform and would be interested to take part to this evaluation. And also we are going to deploy the platform with the key stakeholders in these two pilot domains. Here we have reported, and I think Javier will also talk about the contacts details that we have in our project. Of course, we also keep updating our website with more information on Kraken, but also these are possible contacts for getting in touch with us and helping us to really improve the platform and the pillars that you have seen presented today in the best possible way also in the next months. So I think, Javier,
Thank you. Thank you very much,
I ran
Silvia.
a bit, but maybe I said...
No, yes, we have limited time. Just to highlight that that's one of our target of this workshop, to engage more users for our second round, so feel free to contact us. Well, we booked this slot just for questions. I can read some questions for the audience, trying to summarize them. I don't know if Angel, if you can read one, because I think it's related with the blockchain, because it's unclear for the audience that why we are using the blockchains instead of a regular log, for example, and also in the demo that we saw. That every time a student needs to do something with the evidence, if it's the same case for the health, for the patients of the health pilot, if they have to prompt every time that they need to do something with the data set, if they have to prompt again, one and again, the QRs. So I don't know if you have a chance to read the questions.
Yeah, more or less. Let me first of all clarify. In Kraken, we are going to use two different blockchains. One of them is distributed layering technology. One of them is going to be devoted for using a self-storage identity solution, whether the other one is going to be devoted for payments to help to the end user to pay and buy data from the marketplace. Once I say so, I can talk about the self-storage identity part. I guess, I'm not sure, but I guess that this comment is related with the self-storage identity blockchain or DLT. Well, the main idea here is that the self-storage identity is a transversal or horizontal service. In a project like Kraken, where we have that very different domains with different participants and so on, to have a system like a self-storage identity that allow us to identify the end users to the system in a common way for all type of environments or platforms and so on is great. We can use this social identity approach for using, I don't know, in the hospital or using the marketplace or within the university. And all the thing that I would like to highlight from them and this point of view, this new approach, is that completely user-centric. One of the main things is that the end user is going to have the control of his identity, and he is going to take care and have the final decision about what and how to share that information. Only with that, we can justify the use of this kind of technology, in my opinion. And regarding about the use of QR code and so on, well, the idea is that you don't need to use this QR code for every time you buy or sell a data. The only thing is when you are trying to get into a system and you get into identify with a system, you need to read this QR code. I'm not sure exactly if that is the question of about it, but yes, the idea will be that we need to read the code in order to make available the communication between the website and the mobile that you have, and where is relying the identification process, right? I'm not sure if I answer all the questions.
Yes, that's the problem of the asynchronous conversation. Meanwhile, we have another question for Silvia. Okay.
I read the question. So there is a question about how we evaluated usability. So I was showing in the slides that we asked the user individually to use the system for some days to perform some tasks. And then we used a tool, a very common tool, that is the system usability scale, that is made of 10 questions where user reply if they agree or disagree. And then you have some general scores that can be compared to other systems, especially web systems everywhere that are used. And so that we can compare with this level of usability that we have achieved with the level we would like to achieve. And as I was saying, 68 would be a good level of usability. So we are a little bit below that target that we hope to achieve with the next evaluation round. And then there was another question. Maybe I could say something more about the background of our users. So some of them were asking, yes, more to have more information about the privacy by design measures used by our platform, because they were legal experts and they are very they are following projects in which there are issues related to sharing personal data, and so they were very competent on this sector, and they analyzed very carefully this aspect. And of course, the background of the other participants was more variegated. We had some people coming from research, some others had more experience on blockchain, but some others not. And so we had on purpose a diversified set of users in order to see if all of them could achieve a good level of trust in the platform, and if not, what are the main issues that they may have regarding this platform that we can help clarify and present in a more clear way in the next for the next evaluation round, and of course for the final release of a platform and all its components.
Thank you very much, Silvia. They are talking a little bit more, but because we are running out of time, let me go just for a quick survey. So if you can go, the audience, I'm going to try to copy and paste this. If you can, let me, okay, let me copy this URL, and if you could go to our survey, we are very happy that if you can answer some questions there. So let me go. I'm going to quickly go also. to run. Sorry for that. I think that you can see, you cannot see, sorry, the survey, but the survey is running. I have some problems with sharing my screen on that, but let me, if I could go. Let me, okay. I'm going to share my screen and you can see the results. Well, you can see the control panel, but we can see some audience is interested in participating in our next evaluation round. I'm presenting with another computer, so that's why I'm trying to have here the results. So don't be shy and try to answer our questions. Okay, if no more questions, I will pass to the next. And the next one is that if you are interested in participating in the next Kraken evaluation, but as an infrastructure provider. So the first thing is we would like to have some users participating in our pilot, but also we need some infrastructure providers for the different aspects of our platform. So not the marketplace, because it's part of the Kraken, and Kraken is providing the platform. But for example, if someone wants to host any ledger for the blockchain, or could be a data provider, or could be a data consumer, but always from the infrastructure provider, right? Well, at least we have the 4 same users that they are answering the previous question. And thank you very much. And I'm going to go to the third, is just a question running like a quiz. Okay, and it's just to know in which part are you interested. If participate, in case that you are interested in participating, in which role your organization could be interested in participating in Kraken. That way we can know which aspect we can pilot more, or we can focus on different aspects during our pilot execution. Well, we have the results in our platform. So thank you very much. I'm going to share again my presentation. We have now some information from you. Thank you very much for participating in our quick survey. Sorry for the technical problems of sharing. And just for wrapping up, so we present the 3 pillars of our projects, our project, and also a very important target that we have today in our workshop is to try to engage more users, and that's why Silvia present the evaluation results that we have in the first round of the pilots. So feel free to contact us on this means. So we have our webpage in this URL, and also we have some LinkedIn and Twitter on the social networks, and also feel free to send directly an email to our Kraken mailbox. So thank you very much for attending our session of Kraken, and we hope you contact us for any further information. Thank you very much, everybody, for attending. That's all from our side.
Thank you.
Thank you.
Bye-bye.
Thank you. Bye.
Bye.
Thank you. Bye.
Recording in progress.
Wonderful. So good afternoon, everybody, and a very warm welcome. My name is Martin Kaltenberg from Semantic Web Company, and I'm here together with Jan Jürgens of Fraunhofer and University of Koblenz. And we're happy to welcome you to the Trust session. So what we're going to do now is we have two talks and presentations. Jan Jürgens will start and tell you more about the overall Trust project, give you insights about this area. It's all about data sharing, secure data sharing in data spaces. And as a second talk, I will take over and tell you a little bit more about the importance and how we do interoperability in the Trust environment based on the talk of Jan. So Jan, the floor is yours. I will disappear for a moment and take over later. Thank you.
Yes, thanks a lot, Martin, for kicking this off. And I will now share my slides. Yeah, so as Martin already just said, I now have the honor to give a brief introduction about what the Trusts project is all about. And of course, Martin and myself are only two of the participants in the project. Many more should be mentioned. Of course, some of them are mentioned here on the slide. This includes our coordinator, Alexandra from the University of Hanover, as well as her colleagues supporting her in that role. But of course, the whole consortium, as we will also see on one of the next slides. Yeah, before I get to that, I start off with a very high-level motivation for why I think it's a good idea that the EU invests quite a bit of money in the topic of data sharing and data spaces. With our project, not only, also the other projects in the same funding call that was launched a couple of years ago, but also, of course, still now with the upcoming calls that are still around, many of them around data spaces. And the point is, of course, looking at this figure on the right-hand side of the slide, we can again notice that there is a huge market for data, and unfortunately, the large players are, well, from different continents, not including Europe, which in some sense is fine. As Europe, we don't necessarily have to do everything. That's sort of a global division of labor. On the other hand, there's a threat that because the data is so central now and it will become even more central in the future, you can basically roll up whole business models starting with the data, and you can control in the future many business models if you control the data. And this is, of course, a bit more worrying. So it's important that European industry manages to make some kind of counterbalance against this unbalanced picture that you see here on the slide. And this is the topic of federating IT infrastructures. Of course, there's lots of initiatives now going on, including, for example, also Gaia-X, as we will mention also in this short introduction. But the point here is, from our point of view of the Trust project, for that kind of federation, whether you federate clouds or whether you federate software services dealing with the data, you always need some way of trusted data sharing. So that's the precondition for being able to do that. And this is where we as a project try to support. So that's now the project Trusts. Short context, yeah, we started in the beginning of 2020. We are now approaching the end of our second year. So we have, in fact, quite promising and I think, very exciting results to present. And we have another year to go to finish our project results. Some general motivation and goals. As mentioned already, we need trusted data sharing for personal as well as industrial data, and it really needs to be trusted and secure to be able to be usable. Needs to respect privacy laws, data protection regulations. If you deal with personal data, obviously you have to do that. There's the important issue of interoperability, which, as Martin just mentioned, he will actually talk about in more depth in the second presentation in our slot. Of course, lots of other challenges, scalability, computational efficiency, but in particular, privacy and confidentiality of the data that is supposed to be shared. Yeah, so that's the project. As mentioned already, our coordinator is University of Hanover. Yeah, then there's I think very good consortium of very well-known and very good partners to work with. I don't have to name them all. I think you see them on the slide. So I think it's a really great consortium with lots of exciting backgrounds, which we bring together here in order to push ourselves further to reach the goals, the very ambitious goals that we put ourselves to reach here. So what are these goals? What are the challenges we would like to overcome? Lack of trusted and secure platforms. Therefore, limited sharing of data. And I already mentioned why this is a problem for European industry. And another challenge, diverging standards and quality and legal aspects, which is also a hindrance towards sharing data as much as industry would like to do and would like to be able to. So we would like to address those challenges by developing results, technical results, and also scientific results, which allow the integration and adoption of future data sharing platforms to be able to act independently and also as a platform federator. So also for us, the issue of federation of IT infrastructures is quite central. The concepts we are developing also in particular allow you to federate data spaces. We don't just want to develop one space, but also support the possibility to federate data spaces in various application domains. And of course, we have to investigate the legal and ethical challenges that arise from the goal of wanting to share and exchange data, including personal data and critical and confidential data, and all the regulations that relate to that. So what is our goal and what are the backgrounds we bring into the project to build upon? Goal, again, pan-European solution for trusted data sharing space and the federation of such spaces. Our goal is to help building the digital single market, which of course is an ambitious goal in the EU. And we are quite happy and quite lucky to be able to build on the backgrounds of two very successful projects that have had this goal already, even before the start of the Trusts project, including the Data Market Austria initiative, where there were already research prototypes developed towards the goal that we want to take further in this project, as well as the initiative of the International Data Spaces and the corresponding ITSA association, which is an industry initiative that very much has the goal to develop the topic of data spaces, and where, in fact, currently there's a lot of work and a lot of initiative also towards integrating with other current developments, such as Gaia-X, as mentioned already, where, for example, at the technical level, the IDS connector that we are also using as part of our project here is currently becoming the Gaia-X data space Eclipse connector. So we're having a very tight integration in our project with existing initiatives such as IDS, but also with ongoing initiatives such as Gaia-X on this very technical level by making use of that IDS connector. And this is how we would like to not only develop the technological framework, but also make it usable in the context of these existing initiatives. So just another slide on IDSA. You may have heard about the International Data Spaces initiative already. Just one slide about what the current IDS association looks like. Around 130 companies from across Europe and also beyond that are interested in further developing and using the kind of infrastructure that is developed in the IDS context, and which we are also building on in the context of the Trust projects, So basically, we can also profit from the possible to disseminate our results, for example, in the context of this association. Just another slide on IDS versus Gaia-X. So I mentioned that the IDS connector is currently being integrated in the Gaia-X architecture. And this is basically the picture that corresponds to that statement, where you can see the IDS connector here in the middle of that X, which is the usual abstract description of the Gaia-X architecture and the corresponding goals that are supposed to be reached with Gaia-X. And as you can see, the IDS connector is deeply integrated in that architecture, and this is how we can also link up to this larger initiative from the Trusts project. So AIM, again, creating a secure and trustworthy secure data sharing space for personal as well as industrial data. And second main aim, link the data community, the public and various application sectors via the functionalities that are provided by the Trusts platform. So more concretely, the goal is to set up a fully operational and GDPR compliant, trusted, secure European data sharing space, and to demonstrate and realize the potential of the Trusts platform in 3 business cases that we are also working on as part of the Trusts project. And these are those use cases. So as you can see, they are very much clustered around financial services in different directions. So the first of these use cases is actually directly in financial, namely anti-money laundering compliance. So basically here, finance and compliance meet, and obviously these are very sensitive data that have to be analyzed here and computed in order to make sure that the compliance regulations are being met. And this is therefore a very good demonstrator for Trusts, because Trust has the goal of to be a trusted data sharing space. And that's also something you really need in this use case here. So that's a very fitting use case to the Trust project. The second one is in fact a combination of financial and telecom application domain, where the goal is to be able to do agile marketing through data correlation, where again, the data is also derived from the financial sector. And the goal here is now to be able to do data analytics based on the Trust's data sharing platform, and to develop this into marketing facilities. Of course, again, GDPR compliant, meaning that, for example, you have to make sure that the personal data that is being processed, that this is only done within the agreement of the people who provide that data. Plus, we have to make sure that if data is being shared, that this is being done in a controlled way. So on the basis of bilateral agreement between the data provider and the data analyzer. And so in particular, Trusts is not a data lake where you can just dump in your data and then anyone can have it. But the data sharing has only been done on the basis of agreed contracts and agreed regulations between the data user and the data provider. And third use case, also again arising from the financial sector, but of a more general nature, is that of data acquisition to improve customer support service. Again, of course, an issue which touches on personal data, and so again, the issue of privacy regulations and the compliance is very central here. So yeah, as I said, we are coming towards the end of the second year of the project. So in fact, we have already quite a number of very exciting, I think, results we can mention here, just being constrained by the time available. I give a couple of examples because for time reasons, of course, I cannot present all of them here within these 20 minutes. But some of the things we've done is to produce an analysis of the academic landscape as well as the industrial site conditions and requirements with respect to macro and competitive environment for a trusted data sharing space, taking into account expert voices based on interviews, and in particular also taking into account the telecom and financial industries more specifically, which is also again where our use cases are based. So this is one particular use case and application domain that is particularly interesting for us. And as I mentioned already, we're aligning very closely with existing initiatives such as Gaia-X, but also the EU strategy for data, and of course BDVA and DARO, just as some of the initiatives that are of course very important here and which we are making sure that we are closely lined up with. So some further achievements, as again, I can only give a couple of examples here for time reasons, but I mentioned several times already that because the goal is to be able to also use our platform for personal data, data protection is a very important and very central issue here. So some of the things we're working on is to improve privacy preserving technologies. And indeed, we have been developing several software solutions based on the research in the project, including a new library for private set intersection, which is a very important technique in order to provide privacy-preserving technologies. Encrypted transfer learning prototypes to enable the platform to work on based on encrypted data as far as possible, because as long as you don't have to decrypt the data, your of course your confidentiality levels are much better protected. Denomination risk analysis modules, of course, that's a very important issue because firstly, in many situations, you will anonymize data in order to adhere to privacy requirements. But the risk is always, as mentioned here, that the data might be de-anonymized based on external knowledge that the attacker might have. And therefore, it's important to be able to defend against that. And all of it also including an ensemble learning solution that again supports the privacy preserving technologies. And again, linking up with important initiatives like BDVA, also with respect to our publication strategy. Okay, so I'm getting to the end of my planned 20 minutes before Martin takes over with the second talk. Just a short summary, firstly, of the Trust contribution. We have been developing results that help ensuring the trust in the concept of data spaces by the focus on developing a platform which is based on the multidisciplinary experience of our consortium. The platform allows the integration and adoption of future platforms by means of interoperability, and Martin will tell us more about that in the second part. And we have also been investigating the legal and ethical aspects of this data sharing topic. And in fact, also the Trust platform will be able to act as a platform federator in particular. So just as a final slide, as I mentioned already, of course, we are also having an eye open about future possibilities for realizing projects along the across the topic of data sharing. And as you probably all know, there are actually quite a few possibilities coming up at this very moment, both within Horizon Europe as well as Digital Europe, and obviously based on the results of the projects, many of us will be very interested in pushing things further and thinking about follow-on projects. So if you're interested in the topic of trustworthy data sharing and would like to push this further together with us, then please let us know, and I'm sure we will be happy to talk about this possibility. As such, I'm at the end of my presentation, and as we discussed with Martin, he will now continue with his presentation, and after his presentation, we will then have a joint question and answer session.
Absolutely. Thank you so much, Jan, for this. So we just do the change in our screen sharing, and I hope you can see my screen coming up now, saying trusts.
Yes, very good.
Metadata interoperability. Yeah, thank you so much, Jan. I think that was a very good introduction into the overall trust project, but also already tackling topics about secure data sharing, because there was a question also, we can open it afterwards in the chat, saying, okay, how do you ensure trust in trusts? So nice gaming of word. However, we'll come back to this question. So happy to take over now. My name is Martin Kaltenberg of Semantic Web Company. And here you see the introduction. Well, I introduce myself with a kind of a little graph. So as you can see, I'm CFO and co-founder of Semantic Web Company. We are vendor of a tool that is called Pool Party Semantic Suite that is provided to customers worldwide in the area, and this is the left-hand side here, of knowledge graphs. And we are using semantic web standards, and this standard approach and the knowledge graphs is already a little bit a teaser of what happens now, because going into the next slide, thanks to Jan's presentation, you have already learned about these 4 main contributions of trusts. And Jan already said, I will take over one of these 3. I will take the topic of interoperability here, because trusts has to provide mechanisms for easy metadata and data ingestion, but also integration. And we are somehow a federator between different marketplaces. So what is needed is interoperability. To be sure we are aligned here, I took a few interoperability definitions. So you see there is interoperability, and I will not read it, you can read it yourself. But what does it mean? That systems seamless in principle can communicate and can also work with each other, and they can do it continuously. So without any restriction, as I said here. If you go to the area of data interoperability, you can imagine the next step here. So you say systems that are creating, exchanging, consuming data to have clear shared expectations for the contents, the context. So how is that contextualized, and the meaning of the data that you can find, and that needs to be integrated and needs to be put together. And then there's a very important part of this. So you have seen that mainly, or maybe before, it's the called FAIR principles that come strongly from open science movement in Europe. FAIR stands for findability, accessibility, interoperability, and reuse of digital assets, thereby also data and metadata. And here I want to bring your attention to the bullets that you can see here. So it's the data usually needs to be integrated and need to be integrated with other data, and thereby metadata and data should use a language for knowledge representation. So something that is shared and accessible. Use vocabularies, common vocabularies that we also can use and reuse, describing the data and the metadata, and qualified references. So you find here also the links for sure, and can just follow your nose then later on to learn more about this, but this a little bit about the topic of interoperability, that we are aligned about what this talk is all about. In trusts, our approach of interoperability is realized by a technology and an approach of knowledge graphs, and I will tell you in a minute what that means. But we have built, and we are still maintaining and expanding, the trusts knowledge graph. What does that mean? It's an interlinked system of objects where you find controlled vocabularies, you find all the code lists for the metadata that you need to classify it. You need, it's also used to enable entity linking for metadata and schema, for metadata mapping and schema mapping. What does it mean? When new metadata comes into the system, the metadata usually has a schema that doesn't fit to ours. So we have a centralized schema, centralized categorization systems, and this knowledge graph allows and enables that we can map this incoming metadata with the metadata of trusts. It allows enrichment of metadata by analyzing the data and metadata. Gartner calls that dynamic metadata. So the system goes into the data itself and looks up the named entities, it looks up the classes, it looks up what is inside, and then maps that to the knowledge graph, and thereby you can easily find or you can specify and then find what is in the data, what is in the metadata, and can then say, give me all the data sets that are about a certain statistic in a certain region and maybe in a certain, from a time period, a timeline. And then the system knows exactly where this data is in. That's called dynamic metadata. And it can contextualize, or it contextualizes the data services, but you also have organizations and users in a data space or a data market. So you have to take into account these data space objects, as I call them. This knowledge graph is based on mainly two information models. These information models are based also on other standards already in place. The one is the, I think Jan mentioned it, the IDSA, International Data Space Association information model. And the second one we have taken from the Data Market Austria, the DMA. These are the two projects that Trust is based upon. And we have integrated these models into a new Trusts model that is very, very similar to the ITSA information model. We just have here and there a few ideas and recommendations that this information model can be expanded. And here we go already into the area of interoperability, because every system marketplace data space that is following the ITSA information model then is somehow already interoperable with Trusts. Also, there are several code lists you can imagine, like ISO languages, like DCAT themes. These are classification schemes of data sets, or industry codes. There are taxonomies inside EuroWOC, for example, is integrated, that is used by the European Commission for classification and annotation of nearly all, also the data sets in the European data portal. Domain-specific vocabulary is also along use cases. For example, when you speak about money laundering, FIBO is an interesting one, a finance ontology and taxonomy. And it is based upon established standards for metadata and data management. And for this, I give you one slide without going into the super nitty-gritty details, because this is even not all of the standards that Trusts is using, but it gives a little bit of an overview what is inside this Trusts box. So you see the Trusts IM stands for information model. And then on the left-hand side, and that is very nice, and this helps you already also to go deeper into this topic of interoperability, you see which areas in which colors support to answer a question. So for example, how are things described? How are catalogs organized? You see here the orange or red in the middle. This is DCAT app, a very well used standard established by W3C, but also by the ISA program that is responsible for public administration in the European Union. How are things permissioned? There's ODRL, for example, a W3C standard again, explaining and specifying permissions. How are things accessed? What categories do things belong to? That was EuroWOC that I mentioned before as an example. How are descriptions specified, transmitted, and queries? And finally, what do we expect from data and metadata? And then you see, this is a box in a box. So we are using existing standards to ensure interoperability. And then we put them together so we're using that standards and we're putting these standards together into the Trusts information model. Coming back to the topic of the knowledge graph, because I mentioned this, and here you have a little specification or a definition saying a knowledge graph contains objects and topics that are closely interlinked, classified, semantically enriched, and connected to existing data and documents. Documents are mentioned here because for sure we have unstructured and structured data, and thereby also the knowledge graph supports unstructured data in the form of documents or just floating text. So Trusts can do both of them. And you see here little pictures at the bottom, you have the different sources or the different data repositories where all the data, the content comes in. Then you have a metadata layer and something we call the semantic layer or the conceptual and linguistic model that is combining, explaining the data and metadata. And on top, you can build smart applications that we call semantic AI applications. So this is a 4-layered data or content architecture where this knowledge graph is center in the middle that connects these things, provides meaning, context, as we have seen, what is an important factor for interoperability. Yeah, the good news is a little bit this picture that looks like a big thing, but the good news is that the main part of such a knowledge graph can be done automatically. So you see it, the main part here beneath the water that you usually not see. You can do corpus analysis, RDF transformation, machine learning parts. You can do what I mentioned before or apply it. It's called dynamic metadata, going into the data and the metadata itself and extracting thereby the classes and the categories and the meaning so that you can map your data and metadata to this knowledge graph. There's a very thin layer here to see in our picture that is supervised learning. And then we have a part that is manually created. An information model always needs human beings a little bit that model and integrate the different schemas that we have. We need human beings that really understand the topic, domains experts, if you go into the use cases for domain-specific vocabularies and so on and so forth. How can this be applied? So this is called the knowledge graph, vocabularies, and NLP. So natural language processing in our case here. And it gives you a little bit of an example how this happens, so how this also dynamic metadata works. So on the one hand, you have your models, or you have your taxonomies, ontologies, your basic knowledge graph, and then you apply this onto your data, your metadata, but also to your text, so your unstructured, and you identify and extract, for example, named entities, but also relations. Named entities could be regions, can be topics that you have in your graph, that can be organizations that you have inside the data, and so on. And you map this to your model, and thereby the model is becoming richer because you always have also a feedback loop as a supervised learning. So he says, if there are new concepts that have not been known by the graph before, this can be suggested and put into the graph. And you establish all these links between the different data sets and documents. And thereby on top, you can easily then use unstructured data, semi-structured data, structured data, and map this onto your knowledge graph and put on top something like powerful applications I come to in a minute. Also, looking at the time, I think I'm well in time, but we can use a little bit here for the benefits and the summary. So this Trusts knowledge graph, what are the benefits of it? It provides an interlinked contextualized network of all data space objects. That can be classes, categories, but also the data sets, the metadata sets, and what is inside for sure. All the objects that are relevant. You also have users, you have organizations, maybe you have data related services also in your data space, and that can be used for this. You remember the meaning and the context that was mentioned at the FAIR principles regarding interoperability. So the graph can provide that. The graph furthermore enables search, recommender, and or broker services, if you want to call it like this, but also other data space services. So the data space, the data markets needs a powerful search system. It needs something like a digital broker. We could also call it a recommender system. So imagine you have a profile yourself, you're interested in very specific data sets that you would like to look at. But even then, this system is a learning system. So after, with a time, we can do personalization. The system can suggest to you data sets that could be of relevance for your work or for your use cases, even if they are not in the same category. And this is what it means here with a recommender or broker. It supports a high quality data governance approach. So along the data life cycle that we have in place, the graph can also support in this direction. It enables efficient data and metadata ingestion and delivery. What do I mean with this? As I said, data and metadata is coming in different schemas. in different, with different attributes and so on and so forth. That's a natural thing because usually metadata is modeled by human beings and our construction of the world is a little bit different. So what we're doing here is when data and metadata is ingested, harvested and integrated into the data space, then we already do this mapping that I have explained before, but also the other way around. So when we deliver metadata to a third party, to a federated system, for example, that wants to make use of the metadata and data of trusts, mainly of the metadata, because the data can only be shared for sure and delivered with the okay of the owner or publisher, then we also use this knowledge graph to provide more or less a standard or interoperability in data sharing or metadata sharing. We are standards compliant, as I mentioned before, and I'll show you this big picture. The main standardization organizations here is the World Wide Web Consortium, W3C, and the ISA, the International Standards Organization. And thereby, trusts has it ensures adaptation. So also the trusts technology can be used and reused, and it's scalable regarding its business cases, because Jan has shown 3 of them. That is the main focus of trusts, but with a knowledge graph behind, with a model using standards and ensuring interoperability, you can scale out to more and more use cases. Finally, it's rich in semantics, and that's what's, again, saying this, I said it before, it's providing context, it's providing meaning, and thereby, it's very useful. And all of that together, as you can see here, the assumption of this talk is a knowledge graph is an enabler for data space interoperability. It's also an enabler for interoperability inside an organization for sure, but here it's applied to data spaces. This is the final slide before we maybe open up the panel and have discussions. Have a look if we have questions from your side. If you have any, please put them into the chat of this stream. We are happy to take them directly or answer them also in the chat then. So if you're interested to learn more about knowledge graphs, I have a recommendation of a book that colleagues of mine have been writing and publishing. So the first edition was last year in April 2020. It's also available for free. You just use here the slides, you click the free PDF and you can immediately start reading. It's somehow based on more than 20 years of industry experience. So this book is very much focused on industry use cases, also then handing over to business cases. Yeah, you see it's 7 chapters. It has an addendum, infographics, and what is important also, you have 11 expert interviews about knowledge graphs inside. It's called the Knowledge Graph Cookbook, Recipes That Work. And yeah, just take a look at this, but also get in touch with us with any questions. And this is all from the topic from my side about interoperability in trusts. And let's see where we are and where the colleague is. Jan, you're here again. Did you see if we have any questions, pressing questions?
Yes, in fact, we have several questions in the chat and some nice discussion. So let's maybe start from the top. So Rico Wenning asked about the interesting relationship between Gaia-X and Google, which is indeed interesting. Of course, as Martin also already wrote back in the chat, we are not Gaia-X, we are trusts. I just mentioned the Gaia-X initiative because, of course, it's important for us to keep aligned with important initiatives. But yes, it's an interesting relationship because, obviously no one really wants to somehow be against the hyperscalers. I mean, we are all using their services on a daily basis. Probably literally all of us, and we are glad they exist. Gaia-X has the goal to somehow be able to provide a counterbalance on a global scale, but not the goal to fight the hyperscalers, but to work together with them. And that's yeah, the situation, and Google and also Microsoft are getting involved, and the goal is, of course, to cooperate with them because they have the resources, they have the knowledge, but to be able to establish an infrastructure there that very much is in line with European values and rules. But again, trust is not Gaia X, just basically as a side comment. Although, of course, we have the same goals, basically. So even Trust has the goal to allow data sharing in a way that is compliant with European laws and regulations. So let me see. There was another question from Rico Wenning about the trust ontology or taxonomy to assess trust. And I think your second question in particular shows that it goes in the direction of who can I trust to give my data? So your question is, can I require a certain level of trust for my data to be processed? The point here is, yes, of course, you can. The goal is actually even to decide on a case-by-case data whom a data provider gives their data. So it is not even that you just have like a data trust level and you say, well, I give my data to anyone above the level of 0.5 or whatever metric you want to have. It's not even, it's even more restricted as that because usually you cannot give a global value to the trust that you can give to another company for processing your data in this particular scenario of data sharing, because it really depends on the particular piece of data. So firstly, there may be rules attached what you're even allowed to do with the data. If it's personal data, you need explicit consent of the people from where the data originates for what you can do with it and whom you can pass it on to and what they can do with it. And even if it's industrial data, it's usually sensitive. It may be a company asset, which should not come to in the hands of your competitors. So even though you may trust your competitors in some sense, you may not want to give them your own data. So it really, trust is, I think, in the context of data sharing, not an absolute value, but it really depends on the actual data you want to share. And that's why here in this context, it's really a case-by-case decision whom to make your data available and to define the rules, what they can actually do with the data, and make sure that these rules are actually respected.
Maybe just one sentence, sorry to interrupt you here. So, I mean, trust in data spaces, data markets, it's about data trading and about collaboration in data. And as we also know from our, let's say, business relations, trust comes also a little bit between human beings. And that's something I really want to stress also. So it's not you put it into a data catalog and everybody can, as Jan said, take it out and consume it. It's really bilateral collaboration or trading or buying and selling, demand and supply of data. So this is what data spaces and trust is all about. Thank you.
Yeah. Yes, very much so. There's another question from Rigo about whether we use RDF star, and I think Martin, you are the better one to answer that question. Yes.
Yep. No, we're not using it yet, but I think it's a very good remark and good idea to have a look, because then you can really walk through the edges of a graph and can make additional findings. So we have it on the radar. It's not integrated yet. I think the question came from Rigo, I also saw it before. So we'll have a look at this standard as well.
Yeah. And another, in fact, very interesting suggestion or question, whether the Trust project is considering the Solid project, so the web centralization project, which has been going on for a couple of years now. So we can say that our goals are actually quite similar. So our goal is also to be able to provide a decentralized infrastructure, which allows the possibility of federation of data sharing facilities. And yeah, again, also Solid has the goal to provide decentralization in the context of the web. So in that sense, yes, it is a very interesting initiative. We're not based on it yet, partly probably because of historic reasons, because actually, yes, Solid and the IDS initiative, which is part of our background in our project, have been developed in parallel, both starting about 5 years ago, as far as I can see. And basically, yeah, so Trust is built on IDS as well as the Data Market Austria technologies. So I think the question would be more generally whether it might be interesting to for the IDS initiative to have a look at Solid and see whether it can be integrated. But I think that's, or whether one can at least reuse concepts that have been developed there. But I think it's a good question, a good suggestion, and I think we should take that with us anyway.
Absolutely. I think there was also a discussion between is Solid a W3C recommendation or not. Rigo already, I mean, who could answer that better than Rigo, being the legal counsel of W3C. So it was the basic idea comes from Tim Berners-Lee, as far as I know, but it is still not a recommendation because a W3C recommendation needs to go through a process with a working group, people working together, specifying this recommendation, or call it standard if you want to, and then it will be announced and published. And I think Solid is just not through that process. But I don't want to answer Rigo's part here, and I think that's important. And there was a final one, I think, also on the MyData movement that we also.
Yes, so I think we can say, yes, we're in touch with the colleagues from MyData. So also, again, a very interesting initiative there, which shares many of the goals we have here. So we are talking to colleagues from MyData, in fact. So indeed, the goal should be to come together in the future more closely and basically align with that initiative as well. So it's a very exciting initiative there. I think we should do that, yes.
Definitely. And
that's the last question on RDF. You already answered it.
Yeah, already tried, but we can take it here. So the question was, can RDF provide an interoperability layer between Solid and IDS? So RDF, as the long name says, Resource Description Framework. It's a framework, so it's kind of a language that you can express very many and lots of things, but the work needs to be done. So for sure you can use RDF for this, but the mapping, the writing of the RDF code, so to say, is something somebody needs to do. But for sure you can use RDF for that mapping. That's the idea also for RDF. Okay. Thank you, Rigo. That's a good point. I mean, I know Ruben well. I don't know Lalana, but I think that's a very good point to have a look at the papers and also share that with our colleagues about this Solid and IDS mapping. I think, but I'm not sure, maybe Jan, you know more about it. What I always also been thinking is that a mapping between IDS and the EOSC information model would be very important, because we know we always say European, so we always say, we don't have the Googles, we don't have the Amazons, we are not having this data, but we have this unbelievable rich European open science base, so the EOSC, and they also develop models. So we know this joke, right? The two people coming together and saying, oh, you know, there are 14 standards out there of interoperability. So let's map them together. And what happens is there's the standard number 15 then at the very end. So that should not happen. Do you know if something is going on here already?
Yeah, so at least there are certainly points of contacts with the EOSC initiative. So the European Open Science Cloud, as you say, also a very important initiative for federating, in this case, HP infrastructures used for scientific computations. And yeah, again, I would also think it would be very interesting to align with this initiative. maybe the sort of the distinction between EOSC and JUSTS may be that, at least in our use cases, we have been concentrating more on company use cases and not so much on scientific computing. But of course, that doesn't need to be a sort of a contradiction. In both cases, you need to do intelligent analysis of data. And indeed, I agree that it would make sense to align the scientific and the commercial infrastructures just in order to increase flexibility and efficiency in the use of those infrastructures. And yeah, so that should be very much the goal to do that.
Absolutely. I think there are final discussions about data lakes and semantic data lakes. I would just stress, I put it into the chat already, Gartner calls this a semantic data fabric. Doesn't mean that Gartner is right with everything they say. Don't get me wrong, but I like this idea because it puts more or less the linking and the context and the meaning on top of a data lake, of this idea, putting everything just into a lake, throw it in, and then yeah, magic happens. And we have seen that that didn't really work properly because the magic didn't happen. So, but I think what you mean, Rigo, a semantic data lake is very similar to a semantic data fabric, as Gartner calls it. So it's really then putting in somehow interlinking context, meaning that you really can make more out of the data. You find it again, you get recommendations, you can easily integrate the things and so on and so forth. So I think that's, from my side, at least the answer. Yeah.
Yes, but of course, always keeping in mind the constraints that may be associated with the data. So from the point of view of the user, it's a data lake. So the company that has access to part of the data, that part is a data lake. But it's not one sort of unified data lake where all the data can be accessed by everyone, because the provider of the data may have constraints on who may be able to access it and what they can do with it. Because this is often sensitive data, because it may be either personal or company sensitive data. Yeah, that's usually the data provider makes restriction on which other party may be able to access and use it.
Right. Fully agree here. I think we're good with the questions, but
yeah, and if there are other ones, we still have a couple of minutes. The other questions, please fire them ahead.
Also feel free to get in touch with us on LinkedIn or via the Trust's website. I put it into the chat. So we also can just get in touch with us, but also with our project coordinator, as Jan said, that is the University of Hannover, and fire questions there. And also if you say, we are also working in the area of data spaces or data markets, we're very highly interested to exchange knowledge and discuss together what we have achieved and what you have achieved. So just feel free to contact us for sure. And otherwise we can do a little wrap up and summary, Jan, if you want to.
Yeah, fine with me, yes. So yeah, thanks a lot for all the great questions and discussions. So as the questions and comments also indicated, that in fact the goal of federation of data sharing platform is very important. Several initiatives were mentioned, which are also quite important to what we are doing and have similar goals. So in fact, this emphasizes our impression that yeah, federation is important, being able to federate the different infrastructures that already exist, which have the goal to share data or to share data analysis facilities and infrastructures. Yeah, and this is part of what the Trust project very much wants to do in a trusted, secure and trustworthy environment. And yeah, so thanks a lot again for being able to use some time to present to you what we are doing. If you're interested in more information, as Martin already said, please don't hesitate to get in contact with us. Yeah, and otherwise, again, thanks a lot for your questions and comments. And I leave it to Martin to also say goodbye.
Absolutely. So first of all, thanks to you, Jan, was a fine thing, this double conference that we had the last hour. Thanks to all of you for participation and raising the questions regarding interoperability, also a topic if you're interested, we are happy to discuss. We are also here in touch, maybe to mention, with the BDVA, but also with W3C, with the initiatives going on, because there is more and more standards are developing in the field of data spaces and data sharing, and that's important also. Yeah, that's all from my side. Thank you very much. Thanks to you. Have a great day and enjoy the forum and the conference this and the coming days. Bye-bye.
Thank you. Bye.
Thank you. Cheers.